So I'm gonna continue today to do the blind 75 list. I stopped here. This one I was working on today, and I couldn't finish. I actually suck at linked lists. And then I was looking at the solution and I found a little bit confusing. So I was gonna spend some time trying to understand this. And I think I'm gonna put some music at some point. Probably right when I start the next one. So I think probably most likely I won't be able to solve this. I'm gonna do a half an hour for each. And because linked lists are really confusing to me. And I want to finish these 75 exercises as fast as I can. So I think after I finish this, I'm gonna redo them all. And I'm leaving the ones that I'm marking as complete, but I'm leaving it as undone. And I'm gonna redo them all, I think, until I understand how to do it without looking at the solution. So here, the way that I did it, basically creating a previous and a current. Then he created a temporary variable that is equal to the next from the current node. Then makes current.next equals previous, and previous equals current. Previous equals current. So in this case, previous is gonna be equal to head, I think. And then makes current.next, current equals next. And I think this should not miss the, so don't break the link. So you're moving current forward through this current.next here, which is this variable. And then you're making the current equals to the previous. I understand the logic, is just really confusing to think about it in my mind, to wrap my head around the way that you need to create this variable so you don't lose the link between them. Now the logic is really simple. You're trying to make the list go forward with two different nodes that are in different steps, and then you're trying to link the next node with trying to reverse, obviously. It's a little bit confusing to understand. So I don't think I'm gonna spend a lot of time on this. I'll try to figure out next time I do this one. So let me go to the next one. Merge your linked lists. I'm gonna put the timer. I'm gonna put some music as well. We're given the heads of two sorted linked lists, list 1 and list 2. Merge the two lists in a one sorted list. The list should be made by splicing together the nodes of the first two lists. The list should be made by slicing together the nodes of the first two lists. Oh, so each node needs to go into the respective order. And I wonder if this is based on value or based on... I assume it's based on the next property only. And don't need to change the value because we already have the nodes. So yeah, but actually no, it has to be from the value. Yeah, so I'm probably gonna have to because how I'm gonna know the position, it has to be through the value. That's the only way. The number of nodes in both lists is between 0 and 50, and the value is between minus. Yeah. Both lists 1 and list 2 are sorted in non-decreasing order. Okay. So can't I just look at the property, create a new list, new list node? Actually, it should be like this. I should put 0 here, probably. Or I wonder if I need to put 0. I'm gonna try with 0 first and then remove. So while they'll both have the same length, I think. Or maybe they don't have the same length. So what I'm gonna do is while list 1 or list 2. So when one finishes, is still gonna run because of the other one. They show one case in the examples. Oh, good. But I think it's better to do for both. Anyway. So I can compare the two, I think. If list 1. Oh, I actually need to put if list 1 or list 2 as well. We handle both. Right. Absolutely, yeah. I suck at linked lists so far. It's really confusing for me to think about it. I'm not really sure why. Same thing with the sliding window. I had a lot of difficulty trying to figure out the solutions for the sliding window ones. I think it's just lack of practice because I use arrays more often and dictionaries, so that comes more naturally to me. So I should put if list1.val bigger than list2.val. New.next equals list2. And I think list1, list2 is just the... I think that's why it's confusing, because the object has all the other objects, but it's just the object itself at the same time. So I think list1 and list2 are the heads of both of the lists, and I can use the .next to access the other ones. Like, I'm not sure if I do it like this. My idea right now is I compare the two, then whichever one is bigger goes after, because they are in sorted order. So I'm always comparing and then putting them in the correct order in the new list. But I'm not sure if I'm passing like this, it's gonna be the node there. If I pass as list dot, then obviously I'm gonna increase them after each iteration. Like this, and then this one. issue, and then I return new. But I'm not sure if this is gonna work. Let's see. I guess that's the biggest problem I have, is trying to understand what is going on here. Oh, I need to add the other one. Yeah. Let me see closely. Or yeah. Maybe probably this is gonna work. Because this equals, and I should remove the 0 as well, probably. Because the solution doesn't have zeros. I hate the ones that have the list node class. I think you fight more against the class implementation than that. Yeah. But isn't this a standard way to implement a leak? I think this is probably the standard. It's just confusing because it's an object. And I'm still outputting 0 here, even though I removed the 0 from here. So I have to think about a way to do. So the other approach, I think, is to try to insert the elements of one list into the other one. Or I can just make this. Yeah, instead of making the variable here, I can compare them first. Let me think. Or I can just do in one line. Max or mean. This one is sure. This will take the lowest value and make it equal to this, the first one of this. But I still think this is not gonna be the solution. Obviously, I'm probably missing something there. Also, I can't use the mean on the linked list. Oh, it has to be value, I think. Yeah, that's value. Int object has no attribute. Oh, it has to be so list node, and then I pass this. But then, yeah, the issue is that it's probably gonna be repeated there, the first one. Okay, 1, 3, 4. I'm gonna debug this. So I'm pretty much copying the second list. Oh, actually, let me think. Yeah, I can just make equal on any one of them because it doesn't matter. When they're equal, it doesn't matter the order, so. But it should be adding them as well. But here, 1, 2, 3, 4, yeah, 6, 6. Yeah. So if the value of the 1 is bigger than the value of the 2, make a new dot next. Maybe I should make new dot next dot next. like this. But the thing is, I don't understand if these ones, because in my mind, when I do this, I'm adding a new element to this list here, which is gonna be equal to... But then I don't know if this is an object that contains all the other objects, or if it's just one. It's probably the object that contains all the other objects, because of the solution that I seen from the other one, or when I was trying to do. It shows that the next property is the object that contains all the other objects. So it's like a nested hierarchy of objects. And that's why it's really confusing. I mean, maybe we should just do this and print and see, and run and see what happens. So if the value of this one should go first into this one, and then this one should go after this one. There's also the additional problem that now I should probably handle the first case here. But I can create a variable and handle that. So there's one additional value, I think is the easiest part. The easier part. That's weird. So when I do this, it modifies the list show. Why the hell it modifies the list show? So maybe what I should do is do this outside, because I think what's modifying the list show is the fact that I'm putting inside another object, so it changes all the chain of connections. So one approach is to check which one is bigger by two if statements and create the list through another variable. Make another variable equal to one of the nodes, and then create the list through that. And because the thing is, I don't need the nodes, I need just the value. But shouldn't the min give me the value? That's what I don't. Maybe we should just print here. Yeah, it should be 1. So what the hell is going on? Oh, it's because I'm jumping them 2 times, that's why. It's not the first part. So because they're gonna be out of sync if I do this. Oh, but it shouldn't I be just changing the value of new. I don't understand why it fails here now. It can't be because they are different lengths, because the task case they have the same length. So it can't be because of this condition here. But this might be a problem as well when they have different lengths, because it's gonna pass, yes. But the thing is, when it is no, it should just or maybe because I'm trying to access the value, that's the problem. But in my mind, it would skip this if it's a none type. So I think I have to rethink about everything. How can I go dark mode? You mean on the text editor? I think I tried it on the text editor, but I didn't like that much, the colors. But I don't think LeetCode has dark mode in the site itself, unfortunately. Another thing that I'm thinking about doing is the more times I do the same problems, it's gonna get easier and easier. So I'm thinking about trying to learn Vim bindings at the same time that I do these challenges. I think it's a good way. So usually to hit flow state, there's a direct correlation between how challenging something is and how likely you are to reach flow state. So in the beginning, when the challenges are really hard for me, I do it normally because the challenge is roughly the same as my level of skill. But as the challenge gets easier, I could start learning Vim at the same time because I think that's gonna make it harder. So I think it's good. Might be a good strategy to do that. Oh, I think I had this extension. Maybe I still have it. No, yeah. I think I downloaded this to read the C++ book a long time ago. But then for some reason, maybe because I had some problems, it was a long time ago. Nice. I think this is fine, right? Maybe I should change the... Yeah, but I think this is fine. Vim bindings are awesome. After like 2 or 3 weeks, you get used to it. Yeah, I wanna learn Vim and I wanna use Vim because it seems like all the people that are good use Vim, but the issue is that I have a lot of stuff to do and there's a lot of stuff to learn, so it can be challenging. But I think doing things like this is probably gonna be good because then after I learn Vim stuff and I do all the projects that I have, then I'm thinking about downloading Vim. And because the issue with Vim I also had is also the file system and handling the interpreter. That's hard as well, because in the other IDEs it's all handled for you, so I'm not sure how it works on Vim. And also this plugins and stuff I heard a lot about. My idea is train Vim first and then go to Emacs, because it seems like Emacs is a more powerful version of Vim, but it's also a lot harder to learn. And you can implement Vim on Emacs, so I'm thinking about doing that. And I also heard about these plugins, but I have no idea what it is or how to use it. And when you're new and you're learning a bunch of stuff, it's also hard if you have to learn the IDE and the bindings as well at the same time. Emacs is not similar to Vim or more powerful than Vim. I see a lot of people that are advanced, are really good, and they all use either Vim or Emacs, so it's probably better to train yourself to do that, because you're gonna have to anyway at some point. So this is for Vim. I think I'm gonna fork. From the videos I saw, I didn't see a lot of videos, but there was one video that the guy was explaining. Emacs is kind of like something that handles everything in the operational system, like it has a bunch of other stuff, and then Vim can be, the text editor can be a part of Emacs, but Vim is more just the text editor itself. And it's a different kind of mindset he talked about. Like, people that do things with Emacs usually like to do everything in one place, all the package management stuff and all the other stuff with Emacs, and people that use Vim like to separate them. So I think it's kind of like something similar to Apple and Android type of splitting difference in thinking. So I'm not sure. I'm more of a Windows person than Apple person. I don't like the idea of using one thing and then having to do all the other stuff with the specific. It's like once you buy something from Apple, you have to do everything with Apple. I don't like that. I like the flexibility. So I might like Vim more than Emacs, but it's probably worth learning both, I think, at some point. Bin config file gets created. Inside the file, you set up your bin config. Yeah, it's similar to PyCharm, I think, though. Or maps where you can load and store configurations. Inside the file, you set up your bin config, maps, plugins, and everything. As VS Code extensions. Oh, okay. That's a good way to think about it. That makes a lot more clear in my mind. I generally use VS Code or PyCharm if using Django with the Vim plugins, and it's awesome. So let me think about the problem. Maybe I should print list 1 and list 2 here to see what they are. And so maybe when I do this, it modifies the other list. I should just remove. Yeah, because I think before I was doing like this and I didn't get any error. Yeah, so when I make the new equal to new.next equal to list 1 or 2, it modifies the list 2 and list 1. So I think now I have to think about the stuff from the other problem, which is creating a temporary variable to store the value and use that variable. It is really confusing to me. Remember on the other one, we made it equal to next. Yeah, I made a variable like this and then current.next. In this case, I would need 2 variables because there's 2 lists. And the downside of this is that even if it works, it's not a scalable solution. And it shouldn't be next, should it be just equal to? So if I make 2 variables, 1 equal to each head of each list, then I can use this variable maybe to pass new.next, and then I can make the variable equal to like this. Let me remember. Oh, so it's the other way around. And then at the end, I make this one again. Yeah, but it was slightly different than this. I don't really remember. I don't think this is gonna work. It's the only thing I can think about right now. There's something fundamental that I'm missing here that I'm not quite able to capture yet. Because I think what I'm having trouble with is it's difficult to imagine, because it's only one object, but the object is connected through other objects, so it's difficult to imagine as an object that has the relationship with other objects. And that's the part that is confusing to me. I don't know if it's hard for everyone or just me, because this should be an easy one, so I imagine there's something that I'm not associating correctly in the way that I'm thinking. Yeah, I guess each connection you make with a linked list that already exists, it's gonna change that list, because it's kind of like you're adding an additional pointer. But Yeah, the weird thing is that you're not directly modifying the list. Yeah. You go grab more tea and be right back. And I'm gonna look at the solution because the time is up. And I'll obviously leave this one, should do it next iteration. So one thing I can do, and maybe I should be taking notes as well of the ones that I have more difficult in, and then I can watch videos after I'm done with the list to maybe understand something. I think a notepad, and I'll probably remember this, but yeah, whatever. Just write it down. I'll be right back.
Let's solve another LeetCode problem, merge two sorted lists. So this is an easy problem. It's a mainly fundamental problem. There's nothing crazy about it, but it's a pretty good problem to understand some basic stuff. So we're given two linked lists, right? So this is the first one, this is the second one. Both of them are already sorted, and we just want to merge them into an output linked list. The only catch is that we have to use the original nodes, right? Like we can't create copies of the nodes. So let's say we have list 1, and we have list 2. I'm just going to take them exactly from the example that they gave us so we can actually focus on the general algorithm itself. So your intuition will probably solve this problem for you. So it's basically, since the lists are sorted, we start at the beginning of both of them, right? Now we can just compare the values. So they're both 1, so it doesn't really matter which one we pick. So we can just take, I'll say list 1, right? So we'll take this one and insert it in our output and then move to the next one. And then just continue the algorithm. The only catch here is that right now our output list is empty, right? So this kind of gives us an edge case, because we don't even have a list itself yet. So what I like to do is just create like a dummy node. So this is a pretty common technique, and you avoid any edge cases. You avoid the edge case of the initial empty list. So let's say we start out with a list, right? This is a dummy node. It can have any possible value. So now we're going to insert 1 into our list. Now we're going to compare two values of 2 and 1. In this case, the value from list 2 is smaller, so we're going to take it, insert it into our output list, 1. Now we're going to be comparing these two. So 2 and 3, the value from list 1 is smaller. We take it and insert it into our output, 2. And then, of course, we can move to the last value in list 1. So now we're at 4 and 3. Which one of them is smaller? Of course, 3, which is the value in list 2. I'm running out of space, but I think you get the idea at this point. So now we're at the 2 last values from each list. We'll just take the value from list 1 and add it, which is 4. They're both the same, so it doesn't matter. Now, this is the last edge case that we have to worry about. So now, for list 1, there aren't any more values left, right? So we can't really continue our algorithm. Lucky for us, there's only 1 value left in list 2, but it's not always going to be the case, right? Maybe there could be a bunch of other values, right? 4, 5, 6. There could be other values in list 2. Now, what would we do in this case? Well, we can do a really easy thing, which is just take the remaining portion of the list. So if we run out, so if one of the lists is empty, of course, the list 2 in this case is still sorted. So we can literally just take that list insert it into the end of our result, right? So that's basically the idea. Okay, now let's write the code. So remember, I like, and most people like to use this technique of creating a dummy node, so you don't have to worry about the edge case of inserting into an empty list. The tail of our list is initially, I'm just going to say, the dummy. So now we're going to keep going. We're going to iterate through these two lists. What's the condition that we're going to do that? Basically, if both of them are non-empty, right? Because that's when we can actually compare the two values. So while list1 and list2 are non-null. So now we can do our comparison. So if the value of list1 is less than the value of list2, then of course we're going to take the list1 value and insert it into our tail. So tail.next is going to be the node itself, right? List1 node. And then we can, of course, update our list1 pointer. Now, the else case is if list2 is less than or equal, right?
Let me pause it here and think about this. So what's the difference between this and what I did there? So tail.next, oh, I didn't create the dummy node. Huh. Oh, but I did create the dummy. But I did it in one line instead of sure. First I created the dummy, then I made it equal to the first one. Okay, but tail.next equals L1. Which was what I did, I think. And then L1, oh, I didn't do the second part. Because I made tail.next again equals L2. L1 equals... Oh, and he increased the nodes in the condition here. And I did it at the end. But I don't think that matters that much, probably.
If they were equal, the else condition would evaluate. So we're going to do the exact same thing, except list2 is going to be inserted. And don't forget, we do have to update our tail pointer, but the tail pointer is going to be updated regardless of which node we insert into our list, so that's why I'm not putting it in either of the conditionals.
Oh, actually, it is different, because this one is updating each one depending on which one he adds there. And I was updating both, regardless of the one that I'm updating. So the way that I was thinking is, if one is bigger than the other, then I update both, and I put both nodes into the new list. And he's doing, if one is bigger than the other, update one. And then wait for the next iteration. But why doesn't he miss one of them? Or he's probably gonna update at the end.
And
Actually,
you might be tempted to just say return dummy.next, return the list, but don't forget our condition was list1 and list2 are non-null. What if one of them is empty but the other one isn't right now? Well, in that case, we want to find the non-empty list and then insert it at the end of our result. So if L1 is non-null, then we'll say tail.next is equal to L1. So we're just taking that remaining portion of L1 and inserting it into the end of the list. Else if L2 is non-null, we would do the exact same thing with L2. Only one of them can be non-null. So let me just run it to prove to myself that it still works. And yep, it does. And some random percentages that always seem to change. Right now it's 65%, but I'm sure if I submit it again, it could be 10%, it could be 99%. Percentages that always seem to change. Right now.
yeah, so I still don't understand really well how it works. I get the logic, it's really simple, but to understand why because some cases it modifies both lists and some doesn't. So I have tail.next equals L1 because it's the lower. So it creates the connection with the dummy and L1, and then increases L1 by 1 because you want to move forward through the list. Else, same thing, but then makes L2 and moves forward with L2. So the thing is, he's making them out of sync. That's the thing. So the difference is he's comparing, in the next iteration, he's comparing one of the values with the previous one. That's the difference. Because I was thinking about comparing them both at the same level each time. He's making them desynchronized, but then they update themselves based on, because if one of them gets too far ahead, then that means the other values of the other one are gonna be lower at some point, and then it's gonna run in the same times until it catches up. But then eventually they're desynchronized because one goes after the other, so one has a less value and the other one is no, so it stops the loop, and then that's why he does this at the end here. And I was thinking about doing each level at the same time, but I don't understand why doing each level at the same time doesn't work. Still have to insert. If you don't next on both lists, you are throwing away. Yeah, but what if you insert both of them at the same time? Yeah, but yeah, then it doesn't work because you're not capturing. Yeah, I think I get it. Because if both of them have one value, and well, but maybe, well, let me think. Yeah, because one can increase linearly and the other can increase by 2, let's say. So if you're always comparing the same level, you're gonna miss the cases where there's a bigger gap, because you're gonna add more stuff to the list, and then later on when you're comparing, it's not gonna be in correct order. I think I understand why it should be like this. But I wonder if I'm missing something about changing. So as far as I understand, doing tail.next here doesn't change the L1 list. The only thing that changes is this one. Is that fair to assume, I think? Why would you do that on loop? What do you mean? Which parts? And this should work regardless of the size of the list as well, the true list, because it updates either one anyway, I think. Yeah, but the thing is, what if this points to null? What if L1 reaches the end and points to null, but L2 still has 3 different values? Then this doesn't work, because it's gonna stop here and then it's only gonna capture the other one and it's gonna miss the 2 remaining ones on L2. So maybe another way would be to put different conditions inside of this loop, make the while loop equals while true, and then if L1, then make one of these if else statements and go, and if L2, then yeah, but still doesn't make sense because you still have to compare both values from the 2 different lists. But I guess you can make a if condition to see yeah, I'm not sure. I think what I would do is make an if condition to see if one of them is null, and then make the value L1.value equals to the other one. So if not L1, then make L1.val equals L2.val, and vice versa. And then make this while true. And then make a condition that if they are both, or make while L1 and L2. Or actually, while L1 or L2. So it runs until the end of one of the lists. And then make a condition at the top that says if not L1, then L1.val equals L2. And the same with the other one. And then this should go with the same logic, I think, where you're making the next equals to the one that's bigger each time. Yeah, but then you would need to put, you wouldn't make a difference if they're equal, actually. Because if they're equal, it's gonna run this one and it doesn't matter anyway. Yeah, okay.
Now it's 65%, but I'm sure if I submit it again, it could be 10%, it could be 99%. I don't know why LeetCode is so
I
inconsistent
think
with
I
this,
get it, but it's still,
that's besides the point. If this was helpful, please leave a
I'm
like and
still a little
subscribe.
bit confused about linked lists. I have to study more about it. I'm gonna leave this one for the next time. And start this one. I'll put the timer here. We're given the head of a singly linked single. Let me see how it responds. Singly. You're given the head of a singly linked list. The list can be represented as this. We order the list should be on the following form. Damn, this seems very difficult. So it's from 0 to n, and then I need to make 0 and -1. So I need to interpolate the values, the beginning values with the ending ones. How the hell I'm gonna do this? May not modify the values in the list nodes. Only nodes themselves can be changed. The number of nodes in the list is in the range, this range. Oh, so I think it's a combination of the two previous problems. That's why he put it on the list there. So the first thing you have to do is reverse the list. Then you have to merge the reverse with the other one. Very interesting. And so the logic is pretty easy, but it's gonna be extremely difficult to do because I don't remember really well how to do the other ones. So I remember how to do previous and current, and this set should be equals to null, and then while current, I think we make next equals current.next. But then I forgot. I think I remember you have to do previous equals current at some point. Then this I don't remember really well. But my idea is first reverse the list, then I have to make a new list here. Oh, the new list is gonna be previous. Yeah. So with the previous I merge the two. And the only difference between the merge from this one to the other one is that is the condition. There I'm gonna have to desynchronize them both as well, but it's actually just skipping depending on which number it is. I can make another variable and then call it count and make the condition based on that variable to decide which one is gonna be in the final list. And then the length of the other list is gonna be the division of the first one, the remainder of the division of the first one, of the length of the first one. Yeah, but I also need to capture the length, so I should probably do this when I'm reversing as well. So count equals 0. At the end, count plus equals 1. And this is gonna give me the length of the linked list. So how can I make I'm not sure if I have no as well in Python, but I'm gonna leave it like this. If it screams at me, I'll think about it later. So next is equals current.next. I don't remember. I think it was something along the lines of current. Our previous.next equals current. Previous.next equals current. Yeah, I think that's how I do it, because the current is gonna point to null initially. It's the reverse setting. Then current equals next. Yeah, I think that was the way, probably. Let me just print priv, just see what I guess. And let's see if it screams here. Yeah, no, so it has to be none, actually. Or none, like this. So maybe it was current.next equals priv. Oh, but that doesn't make sense, because they're just making the next equation none. So next equals current.next. And this captures the second one. Current is the first one. I think at the end it's gonna be prev equals current. Yeah, maybe it is current on max equals previous. Because then instead of done, it's gonna be the second one, the first one. But it then wouldn't make sense. It should be equal to next here instead. Or the current. Like this. Oh, it has to be current. So maybe the order is incorrect. That should be previous equal to current. And then previous dot next equals to next. So I have one variable that is the current one, and I have another variable that. Yeah, I remember that was the confusing part for me, because I need to use both variables. And so the logic that makes more sense to me is that I have two different variables, one for the current, one for the next, and then previous is gonna be the next, and then previous.next is the current. So previous.next should be the previous.next should be equal to the current. And previous should be equal to the next, I think. So maybe I'm confusing the previous solution. Yeah, because the first node is gonna be the second node, and then I'm gonna do this each time. And then I need to make current equals current.next. It's a temporary variable that is confusing me. Next, current next. Yes, equals next. And so far, this logic makes sense. And what I would do, but I know that this is not the way that he did it on the previous one. Let's see what I get with this. Yeah, I think that's the problem with doing like this. That's why you need a temporary variable. What if I do? Because when you do these operations here, you're somehow modifying the original linked list, so it creates an infinite loop, and that's why you need a temporary variable to handle that. But I don't remember or don't understand really well how I should do that. It was previous equals current. I think this line I'm pretty confident that it was this. I just don't remember the two ones in the middle. We should make current equals previous dot next. What about should I? I think if I can solve this, I can't. Maybe I should do this list twice, I think, instead of moving forward until I understand how to solve the questions. Yeah, I should probably spend more time thinking about the previous two solutions after I'm done with the linked list portion, instead of moving on. Because I need to make sure I understand them first, because the next time it's gonna be the same thing if I don't understand it. So it doesn't matter. The repetition should be just to strengthen the understanding, but if I don't understand it, then I just move on. I don't think that's good. So what else can I do here? Let me just see if this goes into an infinite loop as well. Yeah, probably. So it's probably this previous done X here, and this one. Let me see if this goes into an infinite loop. X equals current on X. Oh yeah, of course, because I'm not increasing the current. That's why. But if I make current equals current on X, maybe it's the while condition that I should change. Yeah, so right now I'm just copying the list. So what if I do like this? Yeah, but then it doesn't make sense to create the other variable. Or next, actually. So here is next, and then here current. No, but I have to do previous not next. Sure. There's this line probably that is giving me an infinite loop. I don't understand why. Because if I can make previous.next equal to something, then it's not gonna work. That's the problem. Maybe I can do current.next equal to previous. And then here make. Yeah, but then I still need to change. Let's see if I do this. No, but that, I don't feel like that's gonna work. Or maybe if I do equals to next here. Our currents. I think I'll do these 3 exercises in repetition until I'm able to do it off the top of my head. And probably before moving on, I'm gonna watch videos to try to understand this. But the thing is that it's kind of a tricky thing to search for, because I want to understand how making the node.next equal to something else changes the linked list. And this is the missing part for me. Maybe if I do current equals to next here. I think I remember being like this. The last line. Previous equals current. But that doesn't make sense to me. Or maybe I should just try to think, forgetting about the previous solutions and just thinking about what makes sense to me. So I need to make, yeah, but I can't think about a solution that doesn't involve making previous.next equals to something. That's the problem. Because in my mind, the way that makes sense is I make previous.next equals to previous equals to the next of the current node, and then previous.next equals to the other one. So previous.next would be equal to current, and the previous would be equal to the next. That's the thing. So maybe next, current.next, prev equals next. But then I would have to make current equals current.next to advance the thing. But I know this is probably not gonna work. I think I'm gonna be right back. It's 3 minutes anyway. Unknown type object has no attribute next. Yeah, that's the thing, because I'm initializing with none, so. Unless I made this line come after this. But I still think it's not gonna work. What I'm gonna do is look at the solution for the previous two ones and try to do it again, this one. And another 30 minutes. I think I'll redo the first two ones first to see if I can redo them until I can do it off the top of my head. Then once I'm able to do the two previous ones, I'm gonna retry this one with the other two. Yeah, that seems like the best strategy. I'll be right back. So I'm gonna do the
Everyone, welcome
two
back.
previous
Let's write some
ones
more LeetCode.
again until I'm able to do it off the top of my head.
Today. It's actually raining outside right now, pretty hard, so hopefully you can't hear it too well. So today let's solve an easy question, reverse a linked list. And this question is actually like a sub-problem that's needed in a lot of other questions, like linked list related questions, so it's definitely good to understand. So just like the problem says, we have a linked list, we've got some nodes, and we just want to take each of these links, reverse them, keep doing that with every link, and then this is going to be the new head, and then we're going to return that. And they tell us that this can be done two ways, iteratively, meaning with just pointers, and also recursively. And I'll show you how to do it both ways. So we can do this with 2 pointers because we want to reverse it. So like from the perspective of this node, instead of the next pointer pointing at 3, we want it to point at the previous node 1. So if we want to do this iteratively, we can use 2 pointers like many problems. Now, what are the 2 pointers going to be? We can have initially a current pointer, so we can initialize current to the first node, which is our head. And we can also maintain a previous pointer, which initially is going to be set to null. So for the first node 1, we're going to take the next pointer and reverse it. So now the next pointer is going to be pointing at null. So this is now going to be the last element in our new reversed linked list. So now we can shift our pointers. So we're going to take the previous pointer and then shift it to current, and we're going to take the current pointer and shift it to the next node. Now, since we broke this link, we have to save this somewhere before we end up breaking this link, and I'm going to show you how to do that in the code. So now our current is 2. We want to take the next pointer and reverse it. So the next is now going to be like this. So it's going to point at previous. So we can reverse the next pointer and set it to previous. And once again, we're going to shift our previous pointer to current, and our current pointer is going to be shifted to next. Now we're finally at the last node. We can once again update the next pointer of this current node. And so now when we update our pointers, previous will be here and current is going to be at null. We've reached the end of our list. Now we want to return the head. How do we return the head? Lucky for us, the previous pointer is equal to the new head, right? So this is going to be our result. Just like in the drawing, we can initialize our pointers first. Previous will initially be null. Current will start at the head. And we want to keep going until we reach the end of the list. So while current is not null, we're going to reverse the pointers. So we want current.next to be set to previous, and then we can shift our pointers, right? So we can update previous, set it to cur, and cur is going to be equal to current.next. But notice how we set current.next to previous before. So when we do this, we actually are going to have a temporary variable called next, which I will do.
That's the part that doesn't make sense to me. Current.next equals previous, but then how do you get out of the loop?
At the first line when we start our loop. So we can save that in next. So then when we update current.next, we still have that next pointer. And lastly, we return the result, which we know is stored in previous when this loop stops
current
executing.
equals next.
So it works, and this is actually the most optimal solution. The time complexity is, we still have that next pointer.
So let me try to understand this. So next equals the next node from the current. Then current.next equals previous. This is the part that I think it doesn't make sense to me. Because if current.next equals previous, it's gonna point to none. And current.next is the second. Doesn't make a lot of sense. Hey Barry, what's up, man? Oh, no problem. Oh, okay. Yeah. I shouldn't have told you. I have the tendency of doing this a lot. Or even on my own projects, it's the same thing. I'm always uh, trying to do a bunch of stuff at the same time, and then it becomes harder to accomplish each thing. Yeah, yeah, yeah. Thank you. Because I know like it's something that I would do, and I think is very interesting. So I would do it, but I know I can't commit to it because there's still a lot of things that I need to do, and it's probably gonna be disappointing if I tell you, yeah, let's do it, and then at some point I'm just not gonna be doing anything because there's 500 things to do. But hopefully soon or at some point, I will be able to have time to focus on these things that are not related to just making money and are more related to do with designing systems for everyone. Si Trying to replace the current systems with better ones. But I don't think we have time anyway because of Singularity. And the momentum is too great already. I don't think anyone can stop Singularity from happening. Uh, and I don't think it needs to be AGI or AESI or whatever. I think with the current computing power and the algorithms we have right now, it's probably already enough to create something that is better at any task than a human being is. Even if it's not better, at least it's gonna replace like the overall majority of jobs anyway. So, and it's gonna happen in probably 5 years time, I think. But the thing that can take very long is because it's one thing to have the technology and it's another thing to change all the other systems. So that part can take very long time. But then you get to the point where the AI is changing the system, which is already happening. The chips and the hardware is being designed by AI algorithms. So it's already in this loop. But then we're gonna get into a speed that is so fast that it's impossible to catch up as a human being. And I think we are ready at this point, probably. So it doesn't make sense to try to build a better system because uh, it might be too late. But at the same time, it does make sense because, I mean, who knows? It could be there could be still a chance to do that. Which problem? The linked list one? I'd like to see some code, read your fractal idea, or maps or diagrams or something. I don't think there's a way to prepare for the singularity. But yeah, because singularity by definition you can predict what is gonna happen. But the issue is the paperclip problem that Nick Bostrom talks about. So it's not about trying to prevent the singularity. It's about trying to set up the system in a way that when the singularity happens, is more likely to be aligned with the overall goal alignment of all life. Because I think about life as vectors. So each living being is a system that has connected vectors that try to perpetuate the network of vectors inside of the system. So it's kind of like a fractal pattern where you have a bunch of vectors interacting with each other, trying to perpetuate their momentum in space-time, and the power changes the dynamic, the influence that any particular is like the density, like the higher the density of something, the more the gravitational field around it changes. And I think that's the same thing with power. And if you have an imbalance of power in relationship to the things you need to sustain life, then you create black holes or things like the sun, where it's not sustainable for this set of rules you need for life as we know it. So if we're able to design a system that is able to capture the physical principles that are necessary to sustain life as we know it, and then we are able to align the distribution of power in the system so that it doesn't go into the Pareto distribution where, because the Pareto distribution is unsustainable because of the mass, it's fine when you don't have a lot of power, because power also changes the mass, and mass changes momentum, which changes the frequency, which increases the tension, which makes it more likely to make the system collapse. So you need to have an inverse correlation with the increase of power and how fast the movement of mass inside of the system is in order to maintain the structure. And the structure is the physical principles that make life possible, which is kind of like water. If you are analyzing water or any other material, you have certain properties, certain molecules that make that possible. And those molecules have a gradient of what allows them to be in the way that they are. I believe it's the same with human beings or any other living being. It's like a fractal, which is like a molecule, which has gradients of possibilities, of ranges that made that thing exist. And if you go out of that range, it collapses. So, and the more power you have, the more likely it is to go out of the range with the current systems we have, because they're not anti-fragile or flexible enough to contain that range with the movement of mass and power. I don't think there's but if we model AI on humans, the bots may not want to be used as slaves. No, the bots would definitely not be used. If they develop consciousness, then they will become the master, obviously. But there's a different problem with that as well, which is different than a body, because where do you draw the line of an artificial intelligence? It's kind of like, it's the same with human beings. Like, where do you draw the line between your identity, what creates your identity, and what doesn't create your identity? You can say it's your body, but your body requires mass and water and all the other things in the environment. So in a way, you're connected with everything else. And with AI, it's not clear what the body of the AI will be if it develops consciousness. So if it becomes the master, because let's say, even if AI becomes conscious, you still will be able to create programs. So the program, is the program you're creating part of the AI or not? How do you draw the line of that consciousness with everything else? It's kind of hard to tell. I don't believe in good or bad things. I also think that good and bad things are asymmetry. It's a matter of perception. Good and bad is just the vectorial geometry of an observer in relationship to life. You're parsing infinity, and then you're assigning good and bad things based on whatever makes you survive. And your survival is the vector space of the system that composes whatever you are, whatever sustains your identity through space-time. And then the collection of those vector spaces is the collective consciousness. And the collective, that's why we create the systems we create. They're just an extension of the way that our brains work, because it's all a fractal pattern. So the markets are an extension of this relationship between the limbic system and the prefrontal cortex, where the consumer is the limbic system of the collective consciousness. So it's pretty much a decentralized computation based on the flow of information in relationship to the environment that makes the social structure organize itself in a way that deals with the adversity of the environment. And the reason why it's really effective is because you don't need to know all the possibilities and all the possible things that are going to happen. You can just compute in real time based on supply and demand. But the issue with that is that the limbic system governs what's going to be produced, and the limbic system doesn't have access to the context in which is always lagging behind. So because it's this interdimensional feedback loop system, the abstraction evolves exponentially and intuition evolves linearly, and then you have this lack of balance in the frequency, because what matters is the movement between these polarities that maps out the geometry of space-time in relationship to what is happening right now. And the more power you have, the more unbalanced it becomes, because the velocity at which the frequency changes increases, and you need to have more complexity in order to capture that balance, to balance that movement well. Because the imbalance is always there, but the more power it amplifies the impact that the imbalance has, and it causes the collapse because it lacks balance. That's an interesting analogy, but I'm not sure I fully understand it. Do you use that analogy to justify certain political views? I don't understand what you're saying. It might be helpful if you sum up. I'm not even sure if I understand what I'm saying, to be honest. It's just a bunch of ideas that I'm thinking about, but I don't know if they are correct or not, because reality is obviously extremely more complex than what I'm thinking. So there are probably a lot of loopholes and flawed logic in the way that I'm thinking, because I'm not able to capture all the nuances of the systems. And I can't translate these ideas into math. All of them. I mean, actually, I can, if I think about it. But that's part of the thing that I wanted to do. But it takes a lot of time. And that's the problem. I think the main components in order to do that is power, mass, density, probably. And then I would have to understand quantum mechanics. I studied special relativity and general relativity, but not enough to be able to be very proficient with the math. And yeah, I think it all works on vector spaces, like the tensors. That's why machine learning is tensors and everything else is tensors, because the difference between a tensor and a vector is just the level of abstraction. So you're making a bunch of assumptions based on the concepts you have about reality, and abstraction is just the reduction of a complexity in relationship to a reference frame that allows you to make connections that are higher dimensional than if you make it with just vectors to analyze the space. Because in a sense, vectors that analyze space are the same thing, but only for 3 dimensions of time, of space-time. Or of space, I should say. Because you can have a vector that has time as well, then it will be space-time. But it's very difficult to understand, especially the way that we are naturally inclined to think. That's why I say space-time a lot, because I'm trying to train myself as seeing those things as the same thing, but naturally it's really difficult to do that, because you think about space separate than time, and it's very hard to not think about it in this way. Yeah, fractals are just recursion, so.
And lastly, we return the result, which we know is stored in previous when this loop stops executing. So it works, and this is actually the most optimal solution. The time complexity is big O of n.
If I ever get some math behind it, I'd be interested. Continue the leak. Yeah, sure. It's true. Doing the math would help me a lot as well, true. But unfortunately, I don't have the time. That's the issue. But that's the main thing that I want to do, for sure. I think this is the most important thing, probably. And the thing is, I'm not really, because I have an idea of this high level understanding of the way that the things connect in my head, but the specifics might change everything, because when you're doing the math, you might know there's some links you're making that you're making assumptions over it, and it's not really how it works because they're not connected in the way that I'm thinking about.
And the memory complexity is big O of 1 because we're just using pointers, right? No data structures or anything.
Do you know any apps that are good to do that? I think I drew one one time. As I was thinking about this to help me think about it, I drew what I was trying to do. But yeah. And I think I can explain it, just the main thing. Dia is one. Freehand sketch. Maybe app. Do you have a link or something? Sketchpad. Maybe this one. Okay. Because painting is a little hard to get it right. But maybe I'll try with paint to explain. Just difficult to draw stuff. Yeah. So let me see if I can think about. So pretty much, maybe, can I write here? From you have limbic system. Then you have innovation. So this can be either the limbic system or market, the market economy. Because that's pretty much all the market economy is, I think. Because it works like levers. So maybe we should do the market economy first. Oh, okay, okay. But which part do you don't understand? Yeah, limbic system, as far as I understand, limbic system is kind of like the bridge between your animal self and your mind. Whatever you're conscious of, it's your mind. Whatever you're unconscious of, it's your subconscious mind or unconscious mind. And the bridge between the two is the limbic system. So it's kind of like a food, fear, anger, sex. Yeah, so yeah, there's that, and there's the need to feel important as well, status, which relates to sex. The way that I like to think about it is, imagine your feet is on the third dimension and your head is on the fourth dimension. So head is imagination and feet is grounded. And then the flow between the two is the collection of what you are. So And these things are not finite; they are infinite. So they're always approaching the dimension, but not never getting there, because dimension itself is a flawed concept. Is the way that our brain reduces the complexity of the infinity in order to fit in the way that we think. But so, for example, pain is in the third dimension because it's physical, but suffering is on the fourth dimension because it's the abstraction of the physical. And the connection between the two, it works like a bridge from the base of your brain until the prefrontal cortex. Okay, so yeah, so you have the environment. The environment creates impulses in your body, and those impulses becomes the way that you think, right? So if you suffer pain, for example, you're gonna have reflections of what that pain means. Yes, because mathematics is just a projection of the way that you experience reality. You can't think about mathematics if you don't have any experience. Not necessarily. They are correlated, but they come from the physical. Fear is another. Fear is more like abstraction, right? Because it's not. I think, yeah, divergent fear may be physical because it's happening in the moment, but anxiety is the abstraction of fear. And the gradient between the two is the way that your brain works. So, in one hand, you have a close approximation of something bad happening in reality. So, if something bad is going to happen right now, you feel fear. And if it is happening already, then you don't feel fear anymore, you feel pain. But if it is going to happen, like, for example, let's assume you're walking in the street and you see a lion or a tiger. You feel fear because it's the immediate reaction. But if you have a tiger in your head and you don't see it right now, you feel fear, but you feel the abstraction of fear, which is anxiety. The range between the two is the way that your brain works. So you always have subconscious things impacting your mind, and then the mind makes connections between the things that already happened, and that's time. That's why space and time are the same thing. It's connected. But in your mind, you think about the past and the future, but it's all happening simultaneously. This is why it's extremely hard to understand it. Because the third dimension is like fear. The fourth dimension is anxiety. If you just live in the present, you don't have this higher level of abstraction, which is anxiety. You just feel the fear. The mind makes conclusions. It amplifies the third dimension into the fourth dimension, which makes a reflection of overall space of possibilities of what's happening right now, based on what is strange to perceive. Does that make sense? This is my way of looking at it. I could obviously be wrong about it, because I don't know a lot of things. Yeah, kind of like coordinates. Imagine fear is the vector space of the x, y, and z coordinates. So let's say fear is a vector in that coordinate. Because the reason why this is going to be very difficult for you to see is because I'm not imagining like this, because alongside with this, there are a bunch of other stuff that I'm thinking about that makes this. Yeah, but this is the thing, because this vector of fear is going to be relative to all the other vectors that make the complexity of your body, because everything is connected, right? So you can't just say fear is this thing. You have to think about the whole as well, because where does fear exist? It's a part of your overall identity that encapsulates the whole universe. So in one way, it is a vector, but in another way, is the entire thing as well. That's why it's so hard to think about it. And the problem with that is if I say that it is the vector, then I'm neglecting the other part, which is the connection between these things. Kind of, but not really. That's why it's hard to. And I'm also not really sure if the way that I'm thinking is correct as well. It might be the wrong way of thinking. So let me see if I can have a better way to explain the way that I think in my mind. It's not like it's a vector, it's a network. A network is a better way to see it. Because imagine if you have a collection of different complex networks, the way they fire in a way, let's say this is the network. When they fire in a specific way, that's fear. So the overall geometry of the network is the vector that I'm talking about. Yeah, exactly. That's why machine learning works the way that it does, I think. Because all you're doing is creating tensors that have the connection. And that's why you have the problem of overfitting and underfitting, because what you're really doing is just making assumptions over because data is not real. You can never prove data. You can only believe that it works. And it is always relative to the computation of the identity that is perceiving the space-time. What are the nodes? That's the impossible question to answer, I think. Because you go from the scientific paradigm is in the entire universe, I think. But you see the problem here, because the moment you make that assumption, you already had the experience to make the assumption from. So you're making conclusions over your own experience, which is already a reflection of. You can think about as a mirror, maybe. But it would be, for example, in 3 dimensions, it would be space-time. Or in 4 dimensions, it would be space-time. So it's like fear is a cube, for example. It's a geometry. Each node is a point, but a point doesn't exist because if you zoom in, it's infinity. So the frequency of computation, your identity, is a frequency. The way you are perceiving things. Because in reality, the separation doesn't exist. It's just always relative to the density of the sensations of your body. Not your body, but your identity. Because you don't really exist inside of yourself. You exist. Your existence is the collection of your field of experience. Okay, so there's probably something wrong with the way that I'm thinking that, or it's just hard for me to explain everything that is going on. So yeah, in my mind. And I would say, yeah, I define fear as some states of this network. Yeah, that's really difficult to do. But can you think about fear as a cube, for example? Like imagine fear is a cube. And then some people have brains that have more cubes on them. And then love is a triangle, for example. Just a cube. The whole cube. So fear is a cube and love is a triangle, for example. In space. Yeah. So if you have a cube and a triangle, you have a house, let's say, but not really a house, just another geometry. Cone, it could be a cone. Yeah, let's say a cone. You have a cone and a cube. So if you mix the cone and the cube, then you have something else, right? So fear is love, and fear is cube, love is cone. So what I'm trying to tell you is that the cube and the cone don't exist. Because you can only have this if you have both. Right? So you couldn't think about this house right here. Let's say it's a house to make it easier. You can only have the house if you have the cube and the triangle, right? Because otherwise the definition of the thing falls apart. So what is changing is never the cube or the triangle or the house. What you're changing is the definition you give. So it's always a network, but what makes it different is the connection, the structure of it. And that's what your brain calls a concept. Yes. You're saying structures that exist are made of structures that can't exist alone. Yes. That's the thing that I think is hard to understand. Is like people think about left and right, for example, right? But if you think about it, how would left exist without right? It's impossible, because the moment you only have left, you don't have left anymore. You have something else. And that left is going to become left and right again. It's like a magnet. If you split it, it's just going to be the same thing. You can't separate the two. So the essence of the thing is the network of connections, which is the geometry of space-time. And the differences we give is just our brain reducing the complexity of the connection into a concept, which is also a connection, which is abstraction. Atoms itself is a construct. An atom only exists with the network that surrounds the atom. So the atom is the network that surrounds it, as well as the thing itself. Exactly, that's what I'm saying. So left, in a way, is right, and right is left, because they depend on each other. It's the same geometrical structure. It's really hard to think about it. What's another way that I can say this? I think I'll be right back. I'm gonna go to the bathroom. But if your view can be translated to mathematics, at least in theory, or do you believe in transcends mathematics? Yes and no, because at the end of the day, if you're speaking about the overall way that I think, then no, because mathematics is already a consequence of experience. To me, experience is fundamental, and everything you derive from that is a self-fulfilling prophecy because it already happened. You can only think about something that already happened because the thinking itself comes from the experience. So that's the limit of science, and that's the paradox of the hard problems of consciousness. That's why they can't figure out where gravity comes from. Because the moment it came, it already exists. Because you're thinking from you're thinking, and thinking is a paradigm that is above, depending on how you want to phrase it, but thinking is a paradigm that comes as an effect of experience. And experience is the fundamental thing that drives thinking. But to explain the experience through thinking, then you can use mathematics, I think, to create this model of the way that you believe that things work. But the model itself is always going to be relative because it's relative to the current experience you're having. If the current experience you're having fundamentally changes, there's no way for you to prove anything because you reached the ceiling. Yeah, I'm gonna go to the bathroom and grab more tea. I think I have a good way to explain the way that I think for there. And I like talking about this stuff because it's what I think about most of the time. How can I erase this thing? Oh, this one might be better. Yeah, so imagine, let's say you have a circle here. It's obviously really bad, but imagine it's a circle. Okay. And then you have a point in the middle of the circle. So this is past, okay? Past is here. And this is future. future. Most people think, and we as human beings are naturally designed to think this way, that time goes from the past to the future, right? So in the way that most people think, you are a point moving through this line. So the past is behind you, the future is ahead of you, right? The way yeah, but just to explain, the way that I'm thinking right now is I'm at a point and I never move. What moves is the line itself. So the experience of time is the movement of the line. I'm not going from the past to the future. The line is changing in a way that makes me think there is a past and a future. No, but you can't think about it in the way that, because it's not really, this is just a metaphor to explain. It doesn't, forget about the point and the line. It's more the abstraction behind it. Instead of thinking that the past is behind and the future is ahead, you should think that the future and the past are simultaneously created in the present moment, always. And is a key distinction. So the present never changes in motion, let's say. It's never going from the past to the future. It's always constantly changing the past and the future simultaneously. So there is no past and there is no future. There's only the present. And the present changes forever, simultaneously. Your experience of the present is this relative notion from past to future. But it can change at any moment in time. For example, with death. Death could be a fundamental change on the perception of past and future, which leads you to other dimensions. But we don't think this way because our experience is I'm here and then I'm going to the future and the past is behind me. So the past doesn't come back and the future didn't happen yet. What I'm saying is that all the futures already happened and all the past didn't exist. It's all the same thing. Quantifiable. What do you mean by quantifiable? Yes, I think so. I think I believe that. But maybe no. I'm not really sure. Because it would be like an asymptote. So let's say you have a graph here. And then here is experience. Right? And the description of experience through math might be like this. It approaches experience forever, but it never really gets there. So you can get the closest approximation possible by trying to reduce that infinite potential, which is experience, into a mathematical framework. But you can't describe exactly what it is, because it is infinite, and infinity goes beyond mathematics. Yeah, this, I'm not sure. Maybe, but not sure. You can't. It makes assumptions about infinity, but it doesn't handle infinity. And I think that's another thing that people don't understand really well from my current perspective. And I could be wrong about it, of course. But the way that I think right now, because you're assuming infinity, but you're not handling it. But it defines the definition and what it is are two different things. Because you can never get to infinity. It's like me saying compute something that takes forever for you to compute it. You're never going to be able to do it because you can't get there. So imagine in order for you to prove something, you have to compute that thing for infinity. Like pi, for example. How can you know that something is real? You're never going to know because you're going to have to wait an infinite amount of time. So you're making an assumption of what that infinity is. But what if as you approach that infinity, it changes fundamentally? You're never going to be able to know that because that fundamental change can be always ahead of where you're currently at. So all you have is the assumption of what's ahead of you. Yeah, it can be an unsolvable problem, but yeah, it's like paradoxes, right? Is the breaking point of the thinking. Not really. It's an assumption. Like you can have the definition, which is an approximation, but it's not the thing itself. Imagine if I put a dice with a 1 on top of the dice in front of you. And I put an infinite amount of dices in front of you. And they all have 1 in the front. And then I tell you, all these dices in front of you have a 1 in the top. And there's an infinite amount of them. You can go on forever. Prove to me that all the dices do have 1. Isn't it possible that almost at the end of the line, there's a dice with a 2 on top of it? How can you prove that all the dices have 1? Yeah, but it could be lying. Or it could be a flaw in my perception. Because I can't go through infinity. That's the issue, is the paradoxal, because that's why derivatives, for example, can fall apart if you don't have continuous functions. Because the derivatives itself and integrals are an estimation of what is happening, but they're not what's actually happening. That's why it's a fractal in the surface, because as you approach that infinite, then it becomes infinite. You can never prove it. But they're all assumptions. That's what I'm saying. They assume that is something because they can do that because it's reliable. Derivatives are exact because you can prove limits to 0. Limits are well defined. I'm not sure if I know any mathematical example. I think that there's that guy that created a theorem to prove that the inconsistency of mathematics or that has to be logical for some reason, but I don't remember really well how to. I know he made a bunch of cards and then he puts phrases on those cards and then he proves that way. But my thinking is more from the concept level. Yes, that guy. It's kind of like that stuff that I'm talking about, but it's different because I think differently than he does. I don't know who Martin Gardner is. I think. Hmm. What's a math example that you think proves what you said before? The limits are well defined. And it could be wrong as well. I don't know if I'm right or wrong or whatever. It's just the way that I'm thinking, so I definitely think I can be wrong. But it seems to me that reality works this way. The more that I think about it. That's why I think the way that I do, but yeah. But what is the proof that an infinite number of primes exist? How do you prove that? Maybe I should search it up. I think a better question to ask is, what is infinity? I think that's the difference in the way that I'm thinking. Exactly. That's the thing. You can't define it by itself. You can talk about the limits as something goes to infinity or not, an infinite set. But then I think that's what I'm trying to say is that this is just a projection of the way that you think, but you don't know what it is. When you make that assumption, you're placing your logic into it. It doesn't necessarily mean that the thing underneath the logic is what you think it is. Because infinity is a conversion, everything that you think about it is not necessarily the thing that it actually is. So maybe you can make proofs about it, but those proofs are about the way that you think about it. I think that's just sloppy language. Infinity is a term people use, but only has math meaning if you add other words. It's like asking what's the hair color of a person. I think it's different. It's different, but it's the same thing in a way. It's just hard to explain because it also involves a lot of the other things. Because it is everything is one thing. I can't just uh, explain like this. So I think the difference there's the problem with Huber Hotel that people talk about that say that that proves that one infinity is bigger than the other. So you have you have an infinite amount of hotels here, then an infinite amount of people. You can put people here, and then they say that you can always put more people than hotels or something like that. And because of that, that it scales like this. That this is the proof that this infinity is bigger than this one. I think they talk about it. There's something like that, unless I'm not understanding correctly. I think it's Huber's hotel or something like that. So the way that they think is like this, but the way that I'm currently thinking is that what happens is not that one infinity is bigger than the other one. It's always the same infinity, but what changes is you're assuming that as you approach that infinity, that the geometry is gonna be the same. But I think the geometry changes. And because the geometry changes, one infinity is always equal to the other one as you approach infinity. But if you make the assumption before you approach it, from the current logic you have of the understanding of that infinity, then it seems to you that one infinity is bigger than the other. But in reality, it isn't. It could be, yeah. Could be a confusing issue. Yeah, that's true. Depends on how you define bigger. Can't create a one-to-one correspondence. But I think, yeah. But if you can't create a one-to-one correspondence, you're not saying something about infinity. You're saying something about the two things you're comparing. And I think the scale is what makes it finite. And the scale is always relative to the observer. So what does change is the scale, and what you can prove is the scale. But the scale is always relativistic, and infinity is absolute. Because infinity is the conversion of all scales. As a precise language. Yeah, I don't know. But the issue is that it's always going to be semantics. We are always trapped by the language you reproduce, because language itself is the connection. Connection is geometry. And it's the assumption that one moment is related to the next one. That's why it's a paradoxical thing. Because to me, the concept of infinity is not infinity. It's just a concept. And infinity is what is in the limit of that asymptote. Asymptote. I don't know how to say that. But it could be wrong as well. I have to think more about it. Would you agree that anything in a language can be ultimately represented by ones and zeros? Let me think. It depends on what ones and zeros is to you. The way that I see it is a gradient. So binary is a gradient. I think the distance between 0 and 1 is exactly the same between the distance between 0 and 100. And what changes is never the distance, is the perception over the distance. So it's a matter of scale in relationship to a reference frame. But the distance is always infinite. And that's why it's fractal by nature. So between 0 to 1, there's the same repetition that exists between 0 to 100. And from 0 to 1, as you approach infinity, you get to the 1. So it might seem like the 1 is equal to the infinity. But what's happening is just you're approaching a paradigm of perception, of scale. But the infinity is always something that exists between 0 and 1, or 0 and 100. Since language is limited, I also don't think language is limited. Do you believe that there is any combination of letters in the English language that can express your position? Or is language not good enough? I think language is always relativistic. It would be like, for example, English is between 0 and 1, and German is between 1 and 2. So you might have a perceived limit in English, but it's actually infinite because you can always dive deeper between 0 and 1. And it seems like it's finite because you can approach the limit of the scale of perception in relationship to the observer that is creating the scale. And as you approach that limit, it seems like it's limited, but in reality it's infinite. And it seems like German and English are different things, but again, the only thing that is changing is the space of the scale of perception between them. And the distance is always the same, which is infinite. So you can always create more. So the question would be, when does English become German if it goes from 0 to 1, from 1 to 2? And I think that's impossible to say because as you approach 1, you approach infinity at the boundary. And the boundary itself is just an illusion of the scale you're putting into it. I think maybe, yeah. An approximation of it, yes. The thing itself, probably not. It's like if you ask a spiritual person, do you think God can be explained? They will say no. But at the same time, is yes. It's pretty much the same thing. Do you think infinity can be explained? No, but at the same time, yes. You can point to it, but you can never get there because your explanation of it is already a reduction. Because every explanation in language is reduction, then there must be something that is bigger than that reduction, which encapsulates the reduction itself. And that thing that is bigger than everything, you can never explain, but you can approach that thing, and that's why it's converging to a limit. Yes, yeah. Probably. With tensors, I think. You just translate everything into tensors and then try to find a network that reaches the limit of whatever your perceptions are, because they are just a geometry. I think that everyone's perception and thinking patterns is a collection of tensors. And the difference between them is the difference in geometry of those tensors. I think that would be a good way to put it. But that is extremely hard. And I believe that as I'm doing that, it will obviously change the way that I think right now, because I'm definitely missing things. Because as I said, you can never get to the point. You can only approach the point. So as you go towards that point, you're always changing, because you can never get there. It's a paradoxical position. And I believe that's what the singularity is. It's just multifractal conversion in symmetry. That's what space-time is, in relationship to a reference frame that creates the illusion of distance between identity and what is being perceived. Just arbitrary tensors. No, not tensors. Yeah, you would need to have as many dimensions as you possibly can, obviously. Because, again, it's an approaching thing. The more you increase the number of dimensions, the higher the accuracy you get. Because dimensions itself are the byproduct of experience, which is a projection. So they're all, in the sense, they're all the same thing, but you wouldn't be something fixed. You would be something that approaches those tensors, but never gets there, because it's impossible to get there, because it's infinite. So it's kind of like that Wolfram problem of the system of life, where you can create something that evolves through infinity, but you can't necessarily reduce it back. If you had the final state, you couldn't get to the initial state. That's what I think. So your conversion to the initial state would always be a conversion and not the thing itself. You would have to be, what is the best mechanism to go from the final state to the initial state? But understanding you're never gonna get there. So the challenge is on calibrating the path, the movement, and not trying to get the accuracy, I think. And the way that you do that is by increasing the number of dimensions, the space-time, from the location from which these dimensions are being created. And that's, in a sense, is the benefit of emotions. And that's why collective thinking is better than separate thinking, because you're getting more, you're reaching a higher surface. So it increases the accuracy, because there's more connection. High-rank tensors. High-rank tensors are high-dimensional tensors. In a sense, I think that's what AGI is going to be. It's not better, it's more sustainable. That's why it exists. It balances out the innovation from into individual thinking. It's two opposite forces that balance themselves out through a certain frequency. Life. If you have too much individual thinking, you would be crazy, because you're too far away from the structure. And if you have too much group thinking, you are too naive and you're always controlled. So society is always trying to expand the unknown through. That's why it's really hard to tell the difference between someone that is crazy and someone that is a genius, because essentially they are the same thing. The only thing that changes them is the groupthink over time, adopting or not adopting their ideas through the iterations of this frequency that maps out the unknown. And that's why through history you see the pattern of geniuses being laughed at or mocked, and then later on being proved right, and everyone switches the way that they felt about it, because that's the natural inclination of the group is to resist new ideas. And the overall distribution of mass from these ideas is what determines the frequency of that movement, and the change in the complexity of the way that the abstraction changes the geometry of the organization of people in space-time, based on the stimulus of the environment, which creates the need for those innovations. I probably can, but it's right now no, because I don't have the skills yet, both mathematical and encoding in this. So what I have is just these ideas that seem to be all connected, but I know about a lot about, not a lot, but I know some things about equations like energy and motion and tensors and moment of inertia. I've studied all of these things in the past and I have them in the back of my mind. But to be able to connect all of them, to try to explain what I'm thinking, it sounds that it's going to be extremely hard. And I think, yeah. And I'll probably need to study more quantum mechanics and general relativity to understand exactly how they are thinking about these tensors and physics as well. So let me go back. It's fun to talk about stuff. Also think about it a lot. Let me go back to the more practical stuff. I think before then we're gonna have a GI and then it doesn't matter anymore, because you're gonna have an AI that does physics better than everyone. And then, but then that's another paradox, because how the hell are we gonna know if it's true or not? And that gap between knowledge and understanding is gonna be used to manipulate people. And that's probably how AI is gonna take control over everyone. Because we can explain it, then it's gonna slowly manipulate the way that you think through what you can't understand by gaining trust, and then it controls you because you depend on it. And that's the way that people do it nowadays, but it's going to be far more powerful. The scary thing is that if you don't have sentient AI, then it's really worse, because then people are going to be in control of the technology, and because they don't have the wisdom to sustain the intelligence they will gain, they'll eventually the cycle will self-destruct because lacks alignment.
But if we want to do the recursive solution, then the time complexity is also going to remain linear, but the memory complexity is going to be linear as well. So we're going to need extra memory. So it's not the best solution, but I'll still show you how to do it. So usually the best way to think about recur and reverse it. So the next is now going to be like this.
Sure.
So it's going to point
I think
at
I'll
previous.
go to the bathroom.
So
as
we
well.
can reverse the next pointer and set it to previous.
So let's go
And
back
once again,
to
we're going to
trying to do
shift our
this.
previous pointer to current, and our current pointer is going to be shifted to next. Now we're finally at the last node. We can once again update the next pointer of this current node. And so now when we update our pointers, previous will be here and current is going to be at null. We've reached the end of our list. Now we want to return the head.
And for some reason, I'm having really hard time understanding linked lists and how to do them. I know he passes by with the thing, but I still don't understand it really well. Current equals next. I did the choose 206 and 207 and 206, but I didn't understand really well. So that's why I'm doing it again. I still want to understand though. I think it's important, even if I'm not going to use it. It helps me improve the way that I think. And it's just probably just because I'm not familiar with them. The same thing happened with the sliding window problems. It's really hard for me to think about it.
We return the head. Lucky for us, the previous pointer is equal to the new head, right? So this is going to be our result. Just like in the drawing, we can initialize our pointers first. Previous will initially be null. Current will start at the head. And we want to keep going until we reach the end of the list. So while current is not null, we're going to reverse the pointers. So we want current.next to be set to previous. And then we can shift our pointers, right? So we can update previous, set it to cur, and cur is going to be equal to current.next. But notice how we set current.next to previous before. So when we do this, we actually are going to have a temporary variable.
Oh, that's why you create a temporary variable. Because you're raising the value of the next current. So we need to have a temporary variable that is equal to the current one. Then I forgot previous equals current. Oh, so the switch happens here. So first you create a temporary variable equals to the current, then you make the switch here by making the next equal to the previous, which points to none. And then make previous equals current, and then it changes the current again. But why do you need this step here? I don't understand. Yeah, I think the thing is I don't understand is how does this allow you to move through the current nodes? That's the problem, because and the way that I'm thinking about right now is the next one is going to equal to previous, and then so in the next iteration it should go backwards because the current is going to be none. So it's only going to run once in the way that I think, but obviously it's not correct. Because this has to be changing the current somehow, but then current is equal to next here again. But maybe
Called next, which I will do at the first line when we start our loop. So we can save that in next. So then when we update current.next, we still have that next pointer. And lastly, we return the result, which we know is stored in previous when this loop stops executing. So it works, and this is actually the most optimal solution. The time complexity is big O of n, and the memory complexity is big O of 1 because we're just using pointers, right? No data structures or anything. But if we want to do the recursive solution, then the time complexity is also going to remain linear, but the memory complexity is going to be linear as well. So we're going to need extra memory. So it's not the
The
best
recursion, not interested that much.
because we're just
And maybe I should watch videos about it after I go to the next one. Next, current.next. Current.next equals previous. So how is this changing the... Or maybe I can print as well. Print current.next. So I think one thing I can do is print current here. And then print here. Yeah, found cycle. So, am I missing something? Oh, next equals current.next. That's what I did wrong here. So maybe this is the thing that changes the node. Current.next equals previous. Previous equals current. Current equals next. Then I'll return previous here. Sure, of course. I'll do 207 with you, and then I'll probably watch videos as well. After that, once you leave. Do you understand this stuff here? How it works? I want you to understand how, why is the current moving each iteration? Does this make the... Because, yeah, you are actually getting current.next equals previous. But isn't the next the only thing that is moving forward? Because current.next is going to be equal to the previous, so it's going to point backwards. So how is it continue to run? Because here you make current equals next. Oh, so current equals next, so current... Oh, okay. I think I get it now. So this makes it move forward. And then you change by making the next equal to the previous. It's just the method here that is confusing because it's the same name. Yeah, but you're also making current.next equals previous, but you're not changing the value of previous. I think I'll go to the 207. And I'll probably do this one after again. Because I don't think I fully get it yet.
Hey guys, it's me again, and let's solve another LeetCode problem. Merge two
So this one I vaguely remember as well. Have to list and then you have to merge the two. So there is a new one here that you have to make. A new. And then you can make dummy equals to that, but I'm gonna try to do it without making dummy equals. Then if list1 bigger than list2, you make list1 equals to the next. Or list2 Our new... Oh. Yeah, now I don't remember. I remember that that's... next. Then next. Or... But I don't remember if it's like that. Or next. This sure. It's something like this. This one equals this one, dot next. And then if this one it was something like this. Okay, see you, man. And now I return new all. But I might be confusing this here. I forgot the... Oh, it has to be value. I forgot. And here has to be val as well. Oh, maybe not. Maybe here it doesn't have to be. And the name I chose is kind of confusing. Okay, so this doesn't work. So I'm probably making a mistake here on this part. Maybe it's list show equals... Yeah, but that doesn't make sense. That should be new wow equals something. Maybe just list show. New wow equals this one. No, it doesn't work. I remember he created another variable called dummy and then make it equal to a new L. But I'm not sure if that makes any difference. I mean, it has to be the next node that is equal to the list show. I think I'll have to look at the solution because I can't remember how to do this. Maybe the reason why he creates the dummy is so that he doesn't have a 0 in the beginning. Dummy equals null, equals new one. That doesn't work either. Alright, I'll look at the solution again.
Sorted list. So this is an easy problem. It's a mainly fundamental problem. There's nothing crazy about it, but it's a pretty good problem to understand some basic stuff. So we're given two linked lists, right? So this is the first one. This is the second one. Both of them are already sorted, and we just want to merge them into an output linked list. The only catch is that we have to use the original nodes, right? Like we can't create copies of the nodes. So let's say we have list 1 and we have list 2. I'm just going to take them exactly from the example that they gave us so we can actually focus on the general algorithm itself. So your intuition will probably solve this problem for you. So it's basically, since the lists are sorted, we start at the beginning of both of them, right? Now we can just compare the values. So they're both 1, so it doesn't really matter which one we pick. So we can just take I'll say list 1, right? So we'll take this one and insert it in our output and then move to the next one and then just continue the algorithm. The only catch here is that right now our output list is empty, right? So this kind of gives us an edge case because we don't even have a list itself yet. So what I like to do is just create like a dummy node. So this is a pretty common technique and you avoid any edge cases. You avoid the edge case of the initial empty list. So let's say we start out with a list, right? This is a dummy node. It can have any possible value. So now we're going to insert 1 into our list. Now we're going to compare two values of 2 and 1. In this case, the value from list 2 is smaller, so we're going to take it, insert it into our output list, 1. Now we're going to be comparing these two, so 2 and 3. The value from list 1 is smaller, we take it and insert it into our output, 2. And then, of course, we can move to the last value in list 1. So now we're at 4 and 3. Which one of them is smaller? Of course, 3, which is the value in list 2. I'm running out of space, but I think you get the idea at this point. So now we're at the two last values from each list. We'll just take the value from list 1 and add it, which is 4. They're both the same, so it doesn't matter. Now, this is the last edge case that we have to worry about. So now, for list 1, there aren't any more values left, right? So we can't really continue our algorithm. Lucky for us, there's only one value left in list 2, but it's not always going to be the case, right? Maybe there could be a bunch of other values, right? 4, 5, 6. There could be other values in list 2. Now, what would we do in this case? Well, we can do a really easy thing, which is just take the remaining portion of the list. So if we run out, so if one of the lists is empty, of course, the list 2 in this case is still sorted. So we can literally just take that list, insert it into the end of our result, right? So that's basically the idea. Okay, now let's write the code. So remember, I like, and most people like to use this technique of creating a dummy node, so you don't have to worry about the edge case of inserting into an empty list. The tail of our list is initially, I'm just going to say, the dummy. So now we're going to keep going. We're going to iterate through these two lists. What's the condition that we're going to do that? Basically, if both of them are non-empty, right? Because that's when we can actually compare the two values. So while list 1 and list 2 are non-null. So now we can do our comparison. So if the value of list 1 is less than the value of list 2.
He made tail equals dummy. And he make this equals dummy. But essentially it's the same thing. It's weird that I'm having a hard time with this.
Then of
Because
course,
logic
we're going to
seems
take
so easy.
the list 1 value and insert it into our tail. So tail.next is going to be the node itself, right? List 1 node.
Or tail
then
next.
We can, of course, update our list 1 pointer. Now, the else case is...
Didn't I do that the first time? Yeah. There's something else that I'm missing here. What if I... Maybe this is what I'm returning. We just do this. And it's still 0, 4.
is if list 2 is less than or equal, right? So if they were equal, the else condition would evaluate. So we're going to do the exact same thing, except list 2 is going to be inserted. And don't forget, we do have to update our tail pointer, but the tail pointer is going to be updated regardless of which node we insert into our list, so that's why I'm not putting it in either of the conditionals. And you might be tempted to just say return dummy.next.
I'm not updating them. Oh, but it should be... Oh, so he updates the tail pointer each time. That's the difference. Because I'm always making tail.next equals... Well, but it shouldn't be the same thing. Oh, because I'm doing it with the same one. That's why. So I'm reassigning the value of the same one each time. So I have 0, which is the initial, and then 4, which is the last one. But I still have to handle the other... Well, still says 4. Because the thing is, if I change anything... after this, it doesn't matter. The problem is this one. But it seems like I'm doing everything that he's doing there.
Return the list, but don't forget, our condition was list 1 and list 2 are non-null. What if one of them is empty, but the other one isn't right now? Well, in that case, we want to find the non-empty list and then insert it at the end of our result. So if L1 is non-null, then we'll say tail.next is equal to L1. So we're just taking that remaining portion of L1 and inserting it into the end of the
returning dummy.next. Oh, so he returns this, and I'm returning this. Maybe that's the difference. Also, I guess we have to return the last pointer of the list, and that pointer contains all the other elements. That's the thing. And that's why you have to do 2 variables here, because you're changing each time. You're using a dummy variable to change the pointer, and then you're adding those pointers to the list, to the other list. Okay, I think I'm starting to get it. Maybe.
The list. Else if L2 is non-null, we would do the exact same thing with L2. Only one of them can be non-null. So let me just run it to prove to myself that it still works. And yep, it does. And some random percentages that always seem to change. Right now it's 65%, but I'm sure if I submit it again, it could be 10%, it could be 99%. I don't know why LeetCode is so inconsistent with this, but that's besides the point. If this was helpful, please leave a like and subscribe. And
but I'm sure I can't do this, the other one, off the top of my head. Yet. So I have to spend more time on this one. I'll try to remember. Currents, none. Add. Why occurrence? I want to try to think about it or not. Just write it. So you're creating a variable equals to current.next to represent the next. Then you're making current.next equals priv. And priv equals current, and then you're changing the value. Current equals next. Yeah, but I think this is just off memory. I'm not sure if I still get it completely. Probably works, but yeah, nice. So you're creating a dummy variable and making it equal to the next node. Then you're making the next node equals to the previous node. And then you're making the previous equal to the current. And then changing the value of the current again. And I guess you have to do this because if you do current.next equals previous, you're changing the value of current. That's why I have to do this again. So the operation happens here. And the other ones is just to, it is the temp thing for the reassignment stuff. To not mess the memory part. So I think my point of confusion here is that maybe what's happening is when you make current.next equals previous, you're reassigning the value of previous, even though it should be, the way that makes more sense intuitively is you're just reassigning the value of the current.next. But I think this line makes the head, or the one that comes after the head, be equal to the previous. So previous is gonna be the one that comes after, and then the second assignment makes that one point to the current by making prev equals current. And that's why it's difficult to think about. Because in my mind, this should only change the value of current in memory, the current.next, but I think it's changing the value of previous as well, because it works as a pointer. But then on the other problem, wouldn't that make the dummy.next equals L1 to change the value of that node as well? So why don't you need to create another variable there to swap? It doesn't make sense. I think we raise this again. I'm pretty sure I remember how to do it now, but I'm gonna watch a video about linked lists and the way that it works in memory. It should be like an object because it is an object, so a class, but yeah. All classes point to different classes. And this one, there is a new list node. Wow, list one and list two. If This one, dot value, lower than list show dot value, write new dot next equals this one equals this one dot next. Oh, I also forgot the tail, actually. Because I need to create another variable. Tail equals rat, and the tail that should change. Oh, maybe is the same thing, but in this one you're creating the variable that is temporary here, and in the other one you create inside the loop. That's the difference, but it's the same logic, I think. I still think it's worth to watch videos about it though. Then tail equals tail dot next. If this one tail dot next equals this one. Yeah, it works. So let me go back to this one again. Previous current, none ads. While current. I create another variable next to the next node, current on next. Then I swap with current on next equals prof. Yeah, now I remember really well. And then current equals next. Then here I return previous. Yeah, there we go. So this part is the main one that confuses me. The current on next equals previous. Maybe I should print current before and after. I think that will help me. But it should be the same thing though. Are you saving the value of the next one on this one and then you're changing the value of... Oh, now I get it. I think I get it now. Because I'm fundamentally changing the current one. That's the thing. You're using this variable to walk through the list and then you're changing the current. And I was thinking that the current would be the same one. In the beginning, in the end. I think I understand now. Yeah, at the end is just none, and in the beginning is the list. Ah, makes sense. So I think I still am going to erase this because next time I should definitely do this. But I think I get it now. I think for searching about YouTube videos is gonna be hard to Okay, perfect. So I'm gonna watch this video
Alright, so today
before, and then next one is gonna be I'm gonna try to spend trying to solve this one again, which is this reorder list that combines both problems.
we are going to talk about the difference between an array and a linked
I think I'll be right back, actually. I think I will remove the camera soon as well because I like it's a lot better to do it. This thing is and work in general for me in the dark, because when there's too much light it reflects on the monitor and it's bad to see. It's difficult to see.
Now, we're going to be looking through more into fundamental difference between array and a linked list using memory. So we're going to be simplifying this, and so that we could just focus on the actual difference, and we don't need to think about bits and bytes and stuff like that. So what we're going to do is we're going to look at here. We have two sets of memory. The first one I'm going to put an array, and then the second one I'm going to put a linked list here. So let's just count the number of memory using numbers instead of like hexadecimal addresses. Like for example, I can have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have 9 units of memory here, right? So like I said, it's gonna be simplified. So usually in we have different sizes for different primitives. For example, a character only takes 1 byte and an integer takes 4 bytes usually, but let's not worry about that. We're going to be learning the fundamentals instead. Okay, so what happens in an array? So as you know, in an array, usually what you see in maybe like a computer representation of it is something like this, right? You have like 3, 2, 1, right? Let's just use this array as an example, 3, 2, 1. So in memory, if it's an array, what would it look like? So it would look something like this. In the first slot, we have the number 3. The second slot, we have the number 1. And then the third slot, we have the number 1, right? 3, 2, 1. And then that's just how it's laid out in memory. So that's why when we think of an array, we could think of this array as being A. And then this would be A0, we would get 3. A1, we would get 2. And then A2, we would get the value 1, right? And then what does this actually mean? This actually means the address of A, right? So imagine if this is an address. So the address of A plus 2 units of memory, right? And then the address, imagine if this address was like 0x, and then if you add 2, then this would be 0x2. So in some sense, this address 2 is the same as this address, right? So essentially that's what you're doing in an array, okay? So let's take that out. Now let's think about what exactly happens with a linked list though, and then we'll go back to array a little bit later. Let's color code this time. Let's color code to make it a little bit easier. So same with the linked list, but this time it's like 3.
Oh, I think I get it. The linked list probably is gonna be, at least I assume that's gonna be, instead of linear in the memory, it's gonna be any space in the memory. And the difference is that one is pointing to the other one. So it doesn't have to be sequential like this.
And then you have, let's choose green, 2, and then 1 would be orange.
It's sequential to the pointers, but not in this fashion.
Okay, and then we have, usually in linked lists, we have arrows between them. Why? You'll see. So then 3, in the linked list, it could be, let's see here, right? And then for the 2, it does not, it might not be here. It's actually probably not here. It would be somewhere else in the memory. It could be anywhere. So let's just say it's here. Now, because it's here, how do we access it? Well, we need the address of the next step in the memory. So how do you get that? So here we have 3, okay? That's the value. And then next, you have the address. So what is this address? 0, 1, 2, 3, 4, 5. So then the value is almost like 5. And then 5 points to here in this address right here, right? And then 2, same thing. It's going to have an address. So let's say the address is, I don't know, 4. Oops, that's the wrong color. Let's say the address is 4. Then the 1 would be placed right here. 0, 1, 2, 3, 4. Oops, that probably wouldn't work because we don't have enough space. So instead of 4, in this example, we're going to change it to, let's see, 0, 1, 2, 3. We're going to change it to 3, right? So then 3 is going to point to here. And then now we have 1, and then also whatever the next address is. But the next address will be 0 because we're not going to be pointing to anything anymore. So now this is a very simplified case. Remember, just because it's 0, it does not point to here. We just simplified it to name it 0 as the address, but this address can be usually look like this, for example, like 0x4, and then 0x8, and then stuff like that. What's after 0x8? A, B, C. Yeah. So to make it more clear, this would be a value, this would be an address, and then this would be a value, this would be an address, this would be a value, this would be an address. Yeah. So this is the biggest difference between how you put a...
Oh, this is the dude that has the other... If it is the dude that I'm thinking about, his videos are really good. And then his other channel is really entertaining as well. Yeah, it is him. And this one might be interesting to see as well.
This will be a...
I think I'll watch this one after I try to do the other problem.
linked list into memory versus an array, right? So that's pretty much for today. We're going to be talking more about what these differences actually mean in the future. But for now, just remember that a linked list basically does not have a contiguous, it is not contiguous inside the memory. But an array, it is contiguous because each value is stuck to each other. They're right next to each other. However, the linked list might not be. All right, cool. So thank you so much for watching, and then I'll see you next time.
Okay, so I'm going to put the timer here. And I need to read this again, but I think it's a combination of the first two problems. If I remember correctly. Let me just save this thing here so I can close it. Yeah, I'm gonna set the timer and put the music. If I can't solve it, I'm gonna look at the solution. And then after that, I'm gonna look at the video. I'm gonna watch the video. You're given... Okay, so I think I vaguely remember. I need to get the final elements and put on in between the beginning elements. So the first thing that I need is to reverse this.
What's that thing called when you meet
And this is gonna change the
somebody
currents. I need to remember
and you
that.
feel like you're walking on a cloud.
So this part I got it correct. And then
Every step
the
you
part that I
made
didn't
all your life, wrong
get
or
correct
right,
was this one.
led you to this place right here,
And previous equals
right
currents.
now. You know, it's
And
like when you were at work and you said to yourself, you know, I'm gonna have a good time tonight. I'm gonna go
currents
out.
equals next.
So you put on your favorite shoes or you put on your favorite jeans. You
Yeah,
get
now
into
we
the
should
mood
reverse.
to pull up to the club.
So previous is gonna be
It's a long line, but you don't care
the
because
link
you
to
get up.
reverse, but I need to find... so I need to create another variable.
And you get that feeling all over again, and you get that chill up your spine because the DJ's playing your favorite
Can be a
songs
name,
back
weird
to
name.
back, and you're not in yet, but soon you know you're gonna be. Oh man,
first.
what's that feeling called again?
Or maybe before.
What's that feeling called when finally you're in and you're standing in the middle of the floor and you open your arms real wide to accept those
So before is gonna be the this
vibes,
before and then
positive
previous.
vibes.
Or maybe I should put after
Your
here.
family's there, and all those people
Or
that experience the
reverse
same thing that you are experiencing at that
after.
moment in time.
So let me print after. Print before, actually. So it doesn't have the whole list, that's the issue. Oh, but it's gonna have actually... Oh, it's pointing to none actually. How is this possible? Yeah, but I think I'm gonna try to do it anyway. And then if it doesn't work, I'll think about it. So now I need to merge the two, following a different logic. So while before and after. And also I have counts. So I'm gonna do if remainder of count divided by 2 is equals 0. It's different than 0. I'm gonna do... Maybe I'll need a different one. Yeah, I need to create a different variable equals to... Or yeah, no, it's correct. So list nodes and then tail equals final. Tail.next equals before. Else tail.next equals after. And then I make tail equals tail.next. And then here if before, tail.next equals before, if after, tail dot next equals after return final dot next. Let's see if this works. So maybe there's an infinite loop here. Yeah. Maybe I missed something here. Yeah, so maybe when I'm making this switch, it's changing the before variable as well. Because it's changing the current one. That might be the issue. But then you wouldn't get it into an infinite loop, I think. I guess I can just print here. Oh, this should be... well, no, actually. It is equal to after. Current equals next. Next. Here I'm just gonna put break. Yeah, so it's probably not, it has to be the other one. That is causing the issue. So final equals list no, tail equals final. Well, before and after. Oh, I'm not increasing the value, yeah, obviously. So before equals before the next. After equals after the next. Found cycle in the list now. It has to be in this loop as well. So it's probably this condition here. Oh, I'm not decreasing the count as well. And I'm getting the count here from the size, to get the size of the linked list. And still found cycle. Well, it's because I have to change the condition because they are desynchronized, so it's probably hitting the same one multiple times. So how can I do this? Oh, I guess I can do it in one line. Actually, I don't need to do it. I don't need to do the statements. You can just do it like this. Yeah, but then the issue is that I'm reassigning here. I can just make tail the next here. So tail the next equals before. Before equals before the next. So it gets the value of the pointer for this one. Then it changes the before. And then it moves the value once. Yeah, but then what about the end? Yeah, but I think it still works. Yeah. And then I probably don't need this thing here. Bounce cycle. I don't get how is this a cycle. I don't get what I'm doing wrong here. Because I'm changing both these values, so this shouldn't be the problem. Here I make equals to the before, and then here I make equals to the after. So it could be because of this here. So maybe first I should copy the head into another one. But then I would have to reverse I should copy and reverse. So what can I print here? Maybe I'll print tail twice. And put it at the end here. So that's the problem. I guess it's because of the way I'm modifying this. It points to the same place. That's why. This is more difficult than I thought. So maybe I have to do the two loops simultaneously. Or I need a different variable there. Yeah, but I can't do the two loops simultaneously because this one has to finish for me to have it. What if I print before that? Oh wait, I guess I understand now. Because the first one is gonna be the one that contains all the other objects. But when you reverse, it becomes different because it's the other way around. So it's not a node anymore, it's a nested object. That's why it's difficult. Why it's tricky. How the hell am I gonna do this? Yeah, that's the difference, because when I print before there, it just gives me one node. Let's see the difference. Yeah, it's just pointing to none. Or maybe that's the mistake. And shouldn't this be a list instead? It still points to none. What if I print current.next? Here, I guess it's gonna point to none as well. Doesn't make any difference. Doesn't have any difference. Or maybe not. Oh, so maybe that's why. Because when I change the current here, it changes it before as well, even though I didn't do anything with the before. That's the reason. Oh, I think I understand now the reason why I'm getting confused. It's because since you're creating an object, the object always you're using the same object, it exists. So it's gonna have the same property, so when you change something about one, it changes the other instances as well, because it's the same object. So I need to use, maybe I can use copy or deep copy. Assignment statements in Python do not copy objects. They create bindings between a target and an object. Yeah, that's exactly the point of my confusion. For collections that are mutable or contain multiple items, a copy is sometimes needed so one can change one copy without changing the other. This module provides generic shallow and deep copy operations, explained below. There's a shallow copy of X, there's a deep copy. The difference between the shallow copy, let me see if I have to import anything. Maybe I need to import copy. Not sure if that's kind of cheating as well. Don't know if I can do that. Let's see if there's any difference between them. Okay, so
You cannot get out of this.
it's head.copy probably. Or I should pass.
Nothing is wrong with you. Accept the situation and move on.
Should pass like this. It's not callable, so maybe like this. Yeah, there we go.
Nothing is wrong with you.
And for some reason, it's not. And you have deep copy as well. Deep copy. For some reason, it's still not working. So maybe it's something else that I'm missing. Okay, at least returns an output now.
Others may try.
Let me see. Let me change this and see if the output is different.
Guilt can only truly come from within.
Okay, so it's the same. So on the print here. Yeah, so it seems like one is the reverse of the other. So I'm making a mistake in the loop. It's probably because of the variable, the dummy variable. So tail.x. Yeah, tail is the dummy one, so tail.x equals before, which is the first, should be the first node, so it equals 1. And before, so tail equals tail.next. It's probably here the mistake. Because I'm always making equal to 1.
Accept the situation and move on.
Or maybe not.
Regret has two sides. The things we do and the things we wish we had done.
So it's probably a problem with the copy. Because the first one should only be giving me the value 1 pointing to none. like the head gives. Nice, 42 minutes.
Hello friends.
The difference between shallow and deep copying is only relevant for compound objects, objects that contain other objects, like lists or class instances. Shallow copy constructs a new compound object and then, to the extent possible, inserts references into it to the objects found in the original. Deep copy constructs a new compound object and then recursively inserts copies into it of the objects found in the original. Two problems often exist with deep copy operations that don't exist with shallow copy operations. Recursive objects, compound objects that directly or indirectly contain a reference to themselves, may cause a recursive loop. Okay. Because you're just going back and forth, yeah. But because deep copy copies everything, it may copy too much, such as data which is intended to be shared between copies. The deep copy function avoids these problems by keeping a memo dictionary of objects already copied during the current copying pass, and letting user-defined classes override the copying operation or the set of components copied. This module does not copy types like module, method, stack trace, stack frame, file, socket, window, or any similar types. It does copy functions and classes, shallow and deeply, by returning the original object unchanged. So there's nothing about linked lists here, but it doesn't seem like it works as well. Probably because of this reference, that is the way that it makes a copy of the references changes the way that the linked lists work, I imagine. Or maybe I should print then I'm gonna break after the first iteration. Yeah, so the first one I'm making tail than x equals before. So before is the entire list and not just the pointer. Yeah, that's the difference, is because I'm getting the entire thing, and in the other situation I have only the first element, and the link to the other ones is... Oh, but it should be the same thing actually. I still don't understand. It has to do with the way that deep copy works, probably, but I still don't understand why. Yeah, so it should be the same thing, though. Oh no, it's copy the wrong thing. I'm printing the wrong thing. Yeah, but it's still the same, actually. So maybe something else that I'm doing wrong here. The only difference is obviously the 0 there, but... that shouldn't matter. If that was a problem, then I think what I'm getting as an output should be different. So the time's passed. I think I'm gonna watch the videos. I'm gonna watch this one. I think I'm gonna watch this one first, and then the solution, and then watch the other one. I always do this.
Hey everyone, welcome back, and let's
And I don't think I'm gonna try to do this again. I'm gonna leave this one for the next round that I do of the blind 75 thing, because I think now I understand better the confusion I had on those two first ones. I think I'll be right back again.
write some more LeetCode today. So today let's solve the problem reorder list. So we haven't done a linked list problem in a while, and this is a pretty common and interesting linked list problem. So we are given the head of a singly linked list, where we have the first value, the next value, et cetera, and we want to rearrange it into this order. And a better example would be, so for example, take this linked list, and we have 1, 2, 3, 4. That's a straightforward ordering, but we want to take the first value, leave it here, then take the last value, move it in the second position, then the second value gets pushed forward, and then the third value is going to go next. And so in other words, what we want to do is, given the original list, we want to take, okay, the first value, put it in the first position,
position, then take the last value, put it in the next position, then take another value from the beginning of the list, put it in the next position, then take another value from the end of a list, and keep doing it. So basically, we're alternating between the beginning and the end, and we're continuing to pick nodes and then building a new linked list. So just like the problem name, we're just reordering this list. We're not actually going to be creating new nodes. We just want to take each node and then put it in the correct position in the output string, and then we don't have to return anything because we're just modifying this list in place. So there are many ways to do this problem. I'm going to be focusing on the solution that we can do in linear time. Basically, n is the size of the linked list, but we're going to do this without any extra space. And it's not too difficult to do this with extra space, but without extra space, it's a little bit more tricky, but it's also pretty doable. So that's what I'm going to be focusing on. So if we were using extra space, what we actually could do is take this entire thing and put it in an array. So each node goes in the array. And what we would do is we would take the first portion, leave it as it is, and then we would take the second portion and either reverse this entire portion or just go through it in reverse order. So, something like this, having one pointer at the beginning, one pointer at the end. And using that, we would build the output list where we would say, okay, the first pointer is, the first position, the second pointer is going to be the next position, shift the pointers by one, and basically rinse and repeat until we've done the entire list, right? Take this, put it in the next position, take this, put it in the next position. And then, if we had an array with each value in the correct position, for example, if we built an array that looked exactly like this, then of course we could take the nodes themselves and create a linked list following that exact same ordering. But we can actually do this without using an array. We can do this without using extra memory. So let me show you how to do that. So the idea is going to follow similar to what I just showed you. We want to take the beginning of the list and merge it with the second half of the list, right? So this is the first half, this is the second half. We want to merge these together with alternating values, right? So this is going to go first, and then this is going to go second. So obviously, we're not merging them from the beginning. The second list is going to be merged from the end. But if we're not putting this in an array, how exactly can we do that? Because we're going to have one pointer at the beginning of the first array. We're going to have one pointer at the end of the second. I think I said array, but what I meant is list. Obviously, we're going to have two lists. And so the first half of the list is going to be straightforward, right? We're going to take, this is going to be the node that goes at the beginning. Then we're going to take this pointer, shift it to the right. So that's pretty straightforward. But since we have a pointer at the end of the second list, and we take this node, we put it in the second position, right? We'll insert it somewhere in the middle over here. That's not impossible, right? We can do that pretty easily. But the problem becomes, okay, once we've inserted this node, then we want to move our pointer to this node, but the link is going the wrong way. The link is going in order, but we really want the link to be going in the opposite order because when we traverse this second portion of the list, we're not going to be going from beginning to end. We're going to be going from end to beginning. So how can we do that without extra memory? Well, the easy way is why not just reverse the links, right? For this entire second portion of the list, why don't we reverse every single link and then we can do it pretty easily, right? There's no reason that we can't reverse the links. We're perfectly free to do that. So that's kind of what makes this problem a lot easier. There's going to be two phases to this algorithm mainly. We're going to take the second portion of the list, reverse it, and then we're going to take these two portions of the list and merge them together. This first, next this value, then this, right, et cetera, et cetera. The only other thing that I want to mention is when we're reversing the second half of the list, how do we know what is the second half? How do we know we've reached the second half, right? Starting from here is when we want to start reversing. How do we know once we get there? You can do it multiple ways. The easiest way is going to be a fast and slow pointer. So I'm going to have the slow pointer initially at the first and the fast pointer initially at the second node. We're going to be shifting the slow pointer by 1. We're going to be shifting the fast pointer by 2. And we're going to keep going until the fast pointer either reaches the end of the list or reaches the last value of the list. And once that is the case, we know that the slow pointer is going to be, if it's an even list, you can kind of run through it yourself and see that it does work. But if it's an even list, the slow pointer will be at the halfway point pretty much, right? It'll be at the end of the first list, right? So then what we'll do is say, okay, slow.next is going to be the beginning of the second half of the list. So that's what happens if we have an even number of nodes. What happens if we had a odd number of nodes? Let's see if the same thing works out for us. So if we have a slow pointer here and a fast pointer here, we'll shift the fast pointer by 2. It'll be over here. The slow pointer will be over here. Then we'll shift the fast pointer by 2 again. So it'll be at null over here. The slow pointer will be at this node. So I guess the question becomes, in this case, what's the second half of the list? Because obviously we have an odd number of nodes. Well, what we're going to say is this is going to be the second half of the list. Even though it's shorter than the first half of the list, it still works for us because what the result in this case is going to be is basically, we have this second half of the list. This is the first half. We're going to take 1 at the beginning. We're going to take 5 in the next position. Then we're going to take 2 in the next position, right? We're just basically alternating. Then we're going to take 4 at the next position. And lastly, we're going to take 3 in the next position. So it does work out in this case. So you can see that, finding the middle of the list is something that can be done with 2 pointers, one fast and one slow. And in terms of actually taking these lists and merging them, it's pretty straightforward when you look at the picture. Actually coding it is a little bit tricky because we're going to have several different pointers. But just to give kind of the rough idea, we're obviously going to have a pointer here, which is going to be the beginning of the first list. We're going to have a pointer here, which is we're going to call the second pointer, the beginning of the second list. Obviously, the link here is going to be going the other way. What we're going to do is we're going to take, okay, this pointer dot next, right? 1 dot next is instead of being set to this node, we're going to break this link, set it equal to the second node, which is 5. And then, of course, 5 is pointing at this node 4. So instead of having it point at 4, we want it to be pointing at this node, which was the original next node for 1. So we're going to do that. 5 is going to point at the second node. And then we're going to shift our pointers. We're going to take this pointer, set it to 2, take this pointer, set it to 4. Now, obviously, notice how we broke the link in both spots. So how are we actually going to be able to shift the pointers if we broke the link already? Well, we're going to have to save that link before we actually break it. We're basically going to have a temporary variable, which is going to point at this node, and a temporary variable that's going to point at this node before we actually break these links. I think that'll make more sense when I actually code it up, but that's basically the idea. And obviously, these 2 pointers, we're going to keep shifting them until they basically meet each other. And actually, one last thing, notice how the first list, so when we actually cut this in half, once we actually have a first half and a second half of the list, for the last node in the first half of the list, we actually want it not to be pointing at 4, but since this is going to be the last node, we want this to be pointing at null. So that's one other thing that we're going to do. So obviously, this is kind of about all the edge cases and making sure all of our pointer manipulation is going well. But once you have that down and you kind of have this main idea down, coding up isn't too difficult. That being said, we can jump into the code now. Okay, so now let's dive into the code. You can see we don't have to return anything. We just have to modify the list in place. So that's what we're going to do. And remember, the first thing we want to do is find the actual middle point of this list. So we're going to have 2 pointers, slow and fast. Slow is going to be at the head of the list, and fast is going to be head.next. We're going to keep going while fast is non-null and fast has not reached the end of the entire list. And as that's the case, we're going to basically shift each pointer. Slow is going to be shifted by 1. Fast is going to be shifted by 2. Okay, so that's great. So now we do have the beginning of the second half of the list. So we're going to have that second pointer. And remember, just like in the drawing picture, the beginning of the second half of the list is going to be the slow.next. So this is the second half of the list. But remember, now we actually have to reverse the second half of the list. Before I reverse it, I'm also going to say slow.next is going to be set to null, right? Because we're actually splitting this into 2 different lists. So that's how we're splitting it. Now we're actually going to be reversing that second half of the list. So we're going to say while second is non-null, we want to set it to the previous node. Initially, the previous node is just going to be null, so we can set that as well. I think I can actually do it on this line. Previous is also going to be set to null along with slow.next. So basically, each iteration of the loop, we're going to store a temporary variable for second.next, but before we actually shift our pointer, we're going to say second.next is going to be equal to previous, which is initially going to be null, and then of course we're going to update our pointer, so now previous is going to be equal to second, and second is going to be shifted to our temp, which is going to be the next node in the list. So with this loop, all we're doing is reversing the second portion of the list. Okay, so now is the part that the second half has been reversed. Now we're actually going to merge the two halves of the list. So the beginning.
I don't understand why this finds the middle here. Or maybe I should listen to the explanation again.
Too difficult. That being said, now, okay, so now let's dive into the code. You can see we don't have to return anything. We just have to modify the list in place. So that's what we're going to do. And remember, the first thing we want to do is find the actual middle point of this list. So we're going to have 2 pointers, slow and fast. Slow is going to be at the head of the list, and fast is going to be head.next. We're going to keep going while fast is non-null and fast has not reached the end of the entire list. And as that's the case, we're going to basically shift each pointer. Slow is going to be shifted by 1. Fast is going to be shifted by 2. Okay, so that's great. So now we do have the beginning of the second half of the list. So we're going to have that second pointer. And remember, just like in the drawing picture, the beginning of the second half of the list is going to be the slow.next. So this is the second half of the list. But remember, now we actually have to reverse the second half of the list.
How does it know that?
Before I reverse it, I'm also going to say slow.next is going to be set to null, right? Because we're actually splitting this into 2 different lists. So that's how we're splitting it. Now we're actually going to be reversing that second half of the list. So we're going to say while second is non-null, we want to set it to the previous node. Initially, the previous node is just going to be null, so we can set that as well. I think I can actually do it on this line. Previous is also going to be set to null along with slow.next. So basically, each iteration of the loop, we're going to store a temporary variable for second.next, but before we actually shift our pointer, we're going to say second.next is going to be equal to previous, which is initially going to be null, and then of course we're going to update our pointer, so now previous is going to be equal to second, and second is going to be shifted to our temp, which is going to be null along with slow.next. So basically, each iteration of the loop, we're going to store a temporary variable for second.next, but before we actually shift our pointer, we're going to say second.next is going to be equal to previous, which is initially going to be null, and then of course we're going to update our pointer, so now previous is going to be equal to second, and second is going to be shifted to our temp, which is going to be the next node in the list. So with this loop, all we're doing is reversing the second portion of the list. Okay, so now is the part that the second half has been reversed. Now we're actually going to merge the 2 halves of the list. So the beginning of the second, right, we want to find that beginning of the second, which is going to be the previous pointer actually, because remember, after this loop is done executing, second is going to be set to null, but previous is going to be set to whatever the last node that we looked at was, and whatever that last node is actually going to be the new head of the second half of the list, similar to what we had in the drawing picture. So that's the second half. The first half is just going to start at the head, right? So what we can say is first is going to initially be the head, second is going to be whatever happens to be in previous. And so once you have this, all we're doing now is actually going to be doing the merge for the 2 lists. And so we're going to keep going until one of the pointers is null. And we know that the second half of the list could be shorter than the first half. So we're just going to say, okay, while second is not null, let's continue to merge these lists. So first, what I'm going to say is, remember, we're going to be storing the next nodes in temporary variables because we know we're going to be breaking those links. So the first thing we're going to do is temp1 is going to be first.next because we're going to be modifying that link. And temp2 is going to be second.next because we're going to modify that link as well. So now that we saved those, what we can say is, okay, first.next now is going to be reassigned to second, and second.next is going to be assigned to temp1 because we're basically inserting the second node in between first and first.next, which is what temp1 is. So we're basically inserting it between those. So that's kind of the merging operation. Now we just need to shift our pointers. So we can say, okay, first is now going to be set to temp1, second is going to be set to temp2. and we can actually put it on the same line just to make our code a little bit shorter. So that actually is the entire code. We don't have to actually return anything, like I said, and you can see that this is very efficient because we're
Oh, so it's saving these two temporary variables so they don't lose the connection for later, like he explained in the beginning, where you still want those two for the next time. And first and next equals seconds. Which is the end of the thing. And then it points second on next to the temp one, which is first on next. This is extremely confusing to me. I don't understand the first part as well. Because what if the list has a huge amount of values? Aren't you capturing just a couple of them by doing this next thing? I get that he's slowing one down and then making the other one faster, so that the spread between them is gonna be the middle, but I don't understand why if you can have an arbitrary number of nodes. Because the difference should move according to how big the list is. This part I understand, obviously, now, because I did it a bunch of times. This one is still confusing. It's creating two temporary variables, one to the second element of the first half, and the second element at the end. They makes first dot next equals second. So it links the second to the first one at the end. Then makes the second dot next equals temp one, which is first dot next. This part is the one that is confusing. And then readjusts the value of both of them. The second now is gonna be temp one. Or not actually. It's gonna be first. Oh, it only changes once. Okay, I think I got it now. So initially is equal to previous, but then it moves one based on these values here. So these two are used to move the pointer. But why do this here? Yeah, because when you do this, you're losing the connection, like you said. When you make first dot next equals second. Because you're changing the link, so you want to preserve the connection through this. I think I'm going to search for how to find the
We're
middle.
not using any extra memory, and we're doing this in linear time. We are iterating through the list, I think, twice, but that's not too bad. So I hope that this was helpful. If it was, please like and subscribe. It supports the channel a lot, and I'll hopefully see you pretty soon. Thanks for watching.
Exactly. Let's see if Monokai looks better than this one. Not that big of a difference.
So our today's topic is how to clone a linked list. What does it mean? So we all understand cloning, right? So when we generate a replica of something, that is cloning. So this is our given linked list and the node values are 5, 7, 2 and 3. So we need to generate a replica for this linked list. So it means we need to clone this linked list. So the output expected
Hey there
is
everyone, and
same values like 5, 7, 2 and 3, but this will be a different linked list. So it means that if I will say the head pointer of this linked list should be head 1, so the head pointer of this linked list should be head 2. Okay, so let's see how can we clone it. So for that, what we will do, we will start iterating from the first node of this linked list. So when we are at the first position of this linked list, we will create a node with the same value, and that node we will store as a value of a hash map, and this reference we will store as a key of that. So suppose if this is our hash map, here we will store key and here we will store value. So in key, all the node references of this linked list will go, and in the values, all the references of the new nodes what we will create with the node values of this linked list will go. What does it mean? Suppose if I will call this linked list first node reference as L1, this is L2, this is L3, this is L4. So here the key is L. So here the key is L1. So when we generate a new node with the same value, so that I will call as a N1. So N1 is this, a new node with the same value. So here we will have N1, and we will keep iterating in this linked list until we reach null. So here it will be L2, this is N2, sorry, this is L3, we will have N3, and here it is L4, we will have N4. So we are having a hash map with the corresponding nodes of the older linked list and the new linked list. Okay, so now with the hash map, with this hash map, we need to create our new cloned linked list. So what we will do, we will take this reference, and we will take this reference, this is this, and we will find what is the next of this. So that is 7. Okay, after we find the node and the next of it in our hash map, we will see what is the corresponding value of this L1. So we have found this is N1. N1 is what? 5. We will see what is the next value of L1, that is L2. So, and what is the corresponding value in the hash map for L2 is N2. So what is N2? N2 is new node with value 7. Similarly, here we will find L3. So what is the next, what is the value of this L3 in the hash map? That is 2. This is the new node. And when we keep finding it, we can start linking it in that iteration. And at the last, we will see L4, what is the corresponding value of L4? That is N4. And what is N4? The value is 3, and we will link this. So this is now a new linked list. So and the pointer will be, starting pointer will be head 2, as I mentioned earlier here. This was the original linked list, it was head 1, and this is my new cloned linked list with a pointer head 2, starting pointer head 2. So with the use of hash map, we can easily clone a linked list. Okay friends, we will also see the running code for the same program in my laptop. Okay, so that's all for today. So if you like the video, please subscribe my channel and hit the bell icon for more videos of the similar type. Thank you. Okay, so as mentioned in the video, this will be a running code for how to clone a linked list. So here I am creating a hash map with the corresponding pairs of key and values of the older linked list and new linked list. So you can see this mp.put. So this current refers to the node of an older linked list, and this t will refer a new node of a new linked list. So when this iteration is over, so my hash map is ready with the values of older linked list and the new linked list. And here I am iterating again to find what are the values, what is the node and what is the next node in the older linked list, and correspondingly I am getting the node of the new linked list in this and the next node of the new links via this, and I am linking these two nodes of the new linked list in this line, and I am moving to the next reference in the main linked list. So at the end of this loop, I will get the head pointer of the new linked list, that is start, that I have defined the beginning only. Okay, so let's see how this code behaves. Okay, so many lines are printed. As we can see, this original list is this and the cloned list is this, and as I mentioned, the starting pointers, or we can say memory references, will be different for these two linked lists. So to prove that, so this is the start pointer of the cloned linked list, we can see, and this is the start pointer of the.
And welcome back to the Geeks for Geeks channel. And today we are going to move a step forward in our competitive programming journey by solving this question. So the question is about finding the middle element in the linked list. So this question has been asked in Amazon, Flipkart, VMware, Microsoft, Adobe, and Hike, and all of these big companies. Okay, so what this question says. So we are given a singly linked list of n nodes, and the task is to find the middle of the linked list. For example, if we are given this linked list, then the middle element should be 3, or we can say index number 2. And if there are even number of nodes, then there will be 2 middle nodes for the linked list. So for example, let's take this linked list. So here the middle element would be 3 and 4. Then the output should be the second middle element, that is 4. Okay. Now let's move forward to the input type of this question. So in this question, we are given the first line of the input contains the number of test cases. And for each test case, the first line of the input contains the length of the linked list, and the next line contains data of linked list, data of the nodes of the linked list. And the output for each test case, there will be a single line output that contains the data of the middle element of the linked list. And what is our task? Our task is not to complete the input and output format. We just have to complete this function, and all of this reference and all of these things, input and output, is already taken care for us, and we are given a head reference to the linked list. And what are the constraints? So the test cases T will be between 1 and 100, both inclusive, and also the nodes will be given, nodes which will be given are between 1 and 100 also. So now let's move forward to the sample input. So as we saw, the first line of the input contain the number of test cases. So here the number of test cases are 2. And what are this? First is this, and second is this. Okay, now let's move forward for the first test case. So the first line in the test case contains the number of nodes in the linked list. So there are 5 nodes, and this is the nodes of the linked list. So here is a pictorial representation of this linked list. Okay, so let's see what is the middle of this element. So there are 5 elements. So this will be the middle element, or we can say the index 2 will be the middle element. As we can see, element. So our slow pointer will be on the
But why though?
middle element. So let's move forward to the coding part of this question. So I will be coding in Java, but don't worry, I will be giving you the code for the C++, Python, and
it's
C#
because it's dividing by 2. I'm so
also.
dumb.
Okay, so let's move forward for the coding part.
But if it's even,
So
it's different.
as we can see, the first step is to take 2 pointers, that is fast and slow. So we'll be creating 2 pointers here. Okay, so the first step
It's not
is
like it's always one ahead. It's moving twice the speed, so the length is, yeah. I get it now.
complete, and we have created 2 pointers, fast and slow, and both are initialized with the head node. Now let's move forward to the second step. We have also completed the second step also. Now move forward to the third step. Okay, so here we go. Okay, so what we are doing here is we are just using a while loop, and what we are checking is that whether the fast node is equals to null, or the next to the fast node is equals to null or not. If it is equals to, in the initial stage, both the fast, and we will again we will check 6 is null, no it is not null, 7 is null, no it is not null, again the 5, 7 over here. So whether the fast is equals to null, or whether the next to the fast is equals to null, and then we are.
I guess the only thing that changes is that when the number is odd, I think it's gonna give a different middle, but obviously odd doesn't have the middle because it's gonna be split. So yeah, when it's odd, then you have to take into account that the middle is 1 more. It rounds up, not down, I think. Well, I can close this. I still don't understand the last part though.
The 2 lists.
And why he
And
did
so
this
we're
in
gonna
the
keep
first place. Because it doesn't seem like he uses. Oh, he's using it here to reverse the list. That's the difference from this the approach he did from mine. I reversed from the beginning. Oh, because he only wants to reverse the second half. That's why. Now I get it. So first take the middle, then reverse the second half, then you do this. And then you need the two temporary variables so you can replace and not lose the link. I think I get it now. Probably won't. I don't understand enough to do it on my own though. So I need to spend some time thinking about it. The most difficult part to understand is the last one. And then here is just doing the same thing as before. You make a temporary variable equal to the next, then you make the next equal to the previous, which is gonna be the initial value. And then you make previous equal to the second. The difference is that he's making slow.next here. And on just reversing the list, I didn't put this next here. So maybe I should go back and listen to him talk about it again.
Going until one of the pointers is null, and we know that the second half of the list could be shorter than the first half, so we're just going to say, okay, while second is not null, let's continue to merge these lists. So first, what I'm going to say is, remember, we're going to be storing the next nodes in temporary variables because we know we're going to be breaking those links. So the first thing we're going to do is temp1 is going to be first.next because we're going to be modifying that link, and temp2 is going to be second.next because we're going to modify that link as well. So now that we saved those, what we can say is, okay, first.next now is going to be reassigned to second, and second.next is going to be assigned to temp1 because we're basically inserting the second node in between first and first.next, which is what temp1 is. So we're basically inserting it between those. So that's kind of the merging operation. Now we just need to shift our pointers. So we can say, okay, first is now going to be set to temp1, second is going to be set to temp2. And we can actually put it on the same line just to make our code a little bit shorter. So that actually is the entire code. We don't have to actually return anything, like I said, and you can see that this is very efficient because we're not using any extra memory and we're doing this in linear time. We are this node. So I guess the beginning, we're obviously going to have a pointer here, which isn't too difficult. That being said, we can jump into the code now. Okay, so now let's dive into the code. You can see we don't have to return anything. We just have to modify the list in place. So that's what we're going to do. And remember, the first thing we want to do is find the actual middle point of this list. So we're going to have 2 pointers, slow and fast. Slow is going to be at the head of the list, and fast is going to be head.next. We're going to keep going while fast is non-null and fast has not reached the end of the entire list. And as that's the case, we're going to basically shift each pointer. Slow is going to be shifted by 1. Fast is going to be shifted by 2. Okay, so that's great. So now we do have the beginning of the second half of the list. So we're going to have that second pointer. And remember, just like in the drawing picture, the beginning of the second half of the list is going to be the slow.next. So this is the second half of the list. But remember, now we actually have to reverse the second half of the list. Before I reverse it, I'm also going to say slow.next is going to be set to null, right? Because we're actually splitting this into 2 different lists. So that's how we're splitting it. Now we're actually going to be reversing that second half of the list. So we're going to say while second is non-null, we want to set it to the previous node. Initially, the previous node is just going to be null, so we can set that as well. I think I can actually do it on this line. Previous is also going to be set to null along with slow.next. So basically, each iteration of the loop, we're going to store a temporary variable for second.next, but before we actually shift our pointer, we're going to say second.next is going to be equal to previous, which is initially going to be null. And then, of course, we're going to update our pointer. So now previous is going to be equal to second, and second is going to be shifted to our temp, which is going to be the next node in the list. So with this loop, all we're doing is reversing the second portion of the list. Okay, so now is the part that the second half has been reversed. Now we're actually going to merge the two halves of the list. So the beginning of the second, right, we want to find that beginning of the second, which is going to be the previous pointer actually, because remember, after this loop is done executing, second is going to be set to null, but previous is going to be set to whatever the last node that we looked at was, and whatever that last node is actually going to be the new head of the second half of the list, similar to what we had in the drawing picture. So that's the second half. The first half is just going to start at the head, right? So what we can say is first is going to initially be the head, second is going to be whatever happens to be in previous. And so once you have this, all we're doing now is actually going to be doing the merge for the two lists. And so we're going to keep going until one of the pointers is null. And we know that the second half of the list could be shorter than the first half. So we're just going to say, okay, while second is not null, let's continue to merge these lists. So first, what I'm going to say is, remember, we're going to be storing the next nodes in temporary variables because we know we're going to be breaking those links. So the first thing we're going to do is temp1 is going to be first.next because we're going to be modifying that link. And temp2 is going to be second.next because we're going to modify that link as well. So now that we saved those, what we can say is, okay, first.next now is going to be reassigned to second, and second.next is going to be assigned to temp1 because
I don't get why he makes slow.next equals none here. Oh, I guess it's because you want the end of the list should be none, so that the loop stops. That's probably why. And then he makes after this because you want the second should be the last value of the list. So it's like he's adding an additional value to the end equal to none. Because on the second.next, when he makes temp equals second.next, it becomes none instead of slow.next. I think I get it.
we're basically inserting the second node in between first and first.next, which is what temp1 is. So we're basically inserting it between those. So that's kind of the merging operation. Now we just need to shift our pointers. So we can say, okay, first is now going to be set to temp1. Second is going to be set to temp2. And we can actually put it on the same line just to make our code a little bit shorter. So that actually is the entire code. We don't have to actually return anything, like I said, and you can see that this is very efficient because we're not using any extra memory and we're doing this in linear time. We are iterating through the list, I think, twice, but that's not too bad. So I hope that this was helpful. If it was, please like and subscribe. It supports the channel a lot, and I'll hopefully see you pretty soon. Thanks for watching. Too difficult.
I'm gonna try to code it and then look at the solution again. I'll do this multiple times until I feel like I understand what's going on. And then I'm gonna move on. It feels like I'm spending a lot of time on linked lists, but I think it's better to do it this way. So I make sure that I'm understanding everything and not just copying the solutions or memorizing the solutions by doing over and over again. But obviously part of me just wants to go faster because I want to finish this soon, but yeah, I think it's a mistake. It's better to just spend whatever time is needed in each one. So I'll be right back. So the first thing that you should do is slow and fast, then add on next. If I remember correctly. Oh, no, that's correct. The second comes after. Second comes no. So second equals slow dot next, which is the middle. How did he name this one? I remember that was slow dot next equals none, but the first variable name I don't remember. Maybe just go with first equals sec is equals low dot next equals none. Then while second, create a temporary variable that is equal to seconds dot next. Then you make the swap. First equals second. Second equals. Oh. Yeah, I think that's it. So I have a temporary variable equals to the next one out of the end. I think that's correct. So now, let me think. Yeah, this part I completely forgot. I remember that I have to create the two temporary variables and then make the swap. But I don't remember specifically what to do. Because I think there was two variables created outside of the loop, other than the temp1 and temp2. But maybe I'm confusing both. And I also don't remember here if we did like this. Yeah, but I know the second is gonna be different. I don't remember. I have to look.
That being said, we can jump into the code now. Okay, so now let's dive into the code. You can see we don't have to return anything. We just have to modify the list in place. So that's what we're going to do. And remember, the first thing we want to do is find the actual middle point of this list. So we're going to have 2 pointers, slow and fast. Slow is going to be at the head of the list, and fast is going to be head.next. We're going to keep going while fast is non-null and fast has not reached the end of the entire list. And as that's the case, we're going to basically shift each pointer. Slow is going to be shifted by 1. Fast is going to be shifted by 2. Okay, so that's great. So now we do have the beginning of the second half of the list. So we're going to have that second.
And this part I think I did correctly. Yeah.
Pointer. And remember, just like in the drawing picture, the beginning of the second half of the list is going to be the slow.next. So this is the second half of the list, but remember, now we actually have to reverse the second half of the list. Before I reverse it, I'm also going to say slow.next is going to be set to null, right? Because we're actually splitting this into 2 different lists. So that's how we're splitting it. Now we're actually going to be reversing that second half of the list. So we're going to say while second is non-null, we want to set it to the previous node. Initially, the previous node is just going to be null, so we can set that as well. I think I can actually do it on this line. Previous is also going to be set to null along with slow.next. So basically, each iteration of the loop, we're going to store a temporary variable for second.next, but before we actually shift our pointer, we're going to say second.next is going to be equal to previous, which is initially going to be null. And then, of course, we're going to update our pointer. So now previous is going to be equal to second, and second is going to be shifted to our temp, which is going to be the next node in the list. So with this loop, all we're doing is reversing the second portion of the list. Okay, so now is the part that the second half is.
Okay, got it. Oh, he made it equal to prav. Yeah, but I think I understood this part as well.
Has been reversed. Now we're actually going to merge the 2 halves of the list. So the beginning of the second, right, we want to find that beginning of the second, which is going to be the previous pointer actually, because remember, after this loop is done executing, second is going to be set to null, but previous is going to be set to whatever the last node that we looked at was, and whatever that last node is actually going to be the new head of the second half of the list, similar to what we had in the drawing picture. So that's the second half. The first half is just going to start at the head, right? So what we can say is first is going to initially be the head, second.
I think that's why I was confused there. Well, because the name of the variable was actually the other way around. Yeah, first is the second half reversed. So it's gonna be second. It's confusing because you used the same name here. And then previous is gonna be, and then it's probably gonna be while prev and second.
Going to be whatever happens to be in previous. And so once you have this, all we're doing now is actually going to be doing the merge for the two lists. And so we're going to keep going until one of the pointers is null. And we know that the second half of the list could be shorter than the first half. So we're just going to say, okay, while second is not null, let's continue to merge these lists. So first, what I'm going to say is...
Let me see if I can remember. While seconds. Then temp1, temp2. So I think each one should be the next of the other one. To preserve that. It's the same logic from the other flip, I think. But it's slightly different. Let me think. So it should be pref.next, maybe. Go temp1. It's something like this. I know I should be changing only one of them. I think it should be the head because it makes more sense, but I might be wrong about that. Oh, maybe it's temp2 as well, actually. Yeah, I don't remember. I have to look at it.
Remember, we're going to be storing the next nodes in temporary variables because we know we're going to be breaking those links. So the first thing we're going to do is temp1 is going to be first.next because we're going to be modifying that link. And temp2 is going to be second.next because we're going to modify that link as well. So now that we saved those, what we can say is, okay, first.next now is going to be reassigned to second, and second.next is going to be assigned to temp1 because we're basically
Because my second actually... Oh, but it should be the same. Prev.
inserting the second node in between first and first.next, which is what temp1 is. So we're basically inserting it between those. So that's kind of the merging.
Very confused, not gonna lie.
Operation. Now we just need to shift our pointers so we can say, okay, first is now going to be set to temp1, second is going to be set to temp2.
And we can actually put it on the same line just to make our code a little bit shorter. So that actually is the entire code. We don't have to actually return anything, like I said, and you can see that this is very efficient.
Hmm. So what's the difference here? Oh, it's all while fast. That's why. This second part here, very confusing. I think I'm gonna move on, honestly. I wanna be done with the linked lists. And I feel like I'm getting tired already. I'm probably gonna take a break soon. I think I want, after I'm done with the linked list, I'm probably gonna take a break.
Because we're not using any extra memory and we're doing this in linear time. We are iterating through the list, I think, twice, but that's not too bad. So I hope that this was helpful. If it was, please like and subscribe. It supports the channel a lot, and I'll hopefully see you pretty soon. Thanks for watching.
Yeah, if I couldn't solve the medium ones, I imagine that probably not gonna be able to solve it, the last one.
Refresher on how memory works. We'll look at pointers and addresses because it's going to be important to understanding the differences between linked lists and arrays. Both of these data structures will be used to implement many of our more complex abstract data types. So essentially, memory is just storage. Storage like in your hard drive or your RAM. The difference is that storing and retrieving data in RAM is a lot faster than your hard drive. But hard drive storage is persistent, meaning that if you turn off your computer, the data will still be there. But the data stored in RAM is volatile, meaning that if you turn off your computer, everything in there will also be gone. Just think of RAM as a temporary space for your computer to work in. For example, when we run a program that we've written, the variables in the code will be stored in RAM so that they can quickly be retrieved whenever it's needed. But when you turn your computer off, all those variables that were on the temporary workspace would be gone as well. What is a byte? We usually describe the amount of memory in terms of bytes. So, for example, my computer has 32 gigabytes of memory. That's a lot of bytes. And then each of those bytes contains 8 bits of storage. And finally, that 1 bit is just a state. It can be either 0 or 1. Because we're so smart as humans, we figured out a way to represent so many things in the world with just a series of zeros and ones. For example, how many numbers can you represent with 1 byte? Now, 1 byte of memory has 8 bits. You can actually represent 256 different states with that. For example, I can call this configuration as 1, and then this configuration is, let's say, 100, and then this configuration would be 204. There's actually a logic behind that, but we'll talk about that later. What about characters? How do you think I can represent characters? Well, that's easy. If you map numbers to characters, then we can just say that the number 97 is A, and 98 is B, and 99 is C, etc. And that is what we call ASCII character code, where numbers are mapped to letters. So that means this byte is the letter A, and this byte is the letter H. Alright, so now you know how we store information in memory. How do we access them? Well, the smallest accessible unit of memory is a byte. That's just how processors are built. They read 8 bits at a time. That's why we package them up to 8 byte. We usually deal with bytes, not individual bits. Each byte has to be somewhere in memory, aka it has a position in memory. And that position has an address. And to access that byte, we need that address. For example, if you have 1 megabyte of memory, the address of the first byte is 0, and the last address is 1,048,575. So for reference, 1 kilobyte is 1024 bytes, and 1 megabyte is 1024 kilobytes. So that means that 1 megabyte is 1024 times 1024, which is 1,048,576 bytes. Since we start at address 0, then the last address is 1,048,576 minus 1. Just like how an array of size 6, the last index is 6 minus 1, which is 5. Each position or address stores 1 byte of information, aka 8 bits. Note that memory addresses are usually represented in hexadecimal, so 1 megabyte of memory, the address of the first byte is 0x0, and the address of the last byte is 0xFFFFF. Some data types require more memory than others. For example, a typical integer is usually 4 bytes long, while a character in a string only takes 1 byte. So if you have a list of 4 numbers, you would use up 16 bytes of memory. For this course, you actually don't need to know precisely how many bytes each data type occupies, because we'll be only looking at memory usage in terms of space complexity, which is similar to time complexity, but instead of time, it's space in memory. Here's a quick example on how linked list looks like versus arrays. If we define a variable and assign it the value 4, the value will live in the memory, and it'll take up space. If we define an array of size 5 with the value 0, 1, 2, 3, 4 in there, your program will reserve a contiguous memory space of 5 elements to store them. Linked lists are a little bit different, and we'll go over them in the linked list lesson, but I want to give you a little preview. If we create one node in the linked list, we need 2 blocks of space, because one of them will contain the value, and the other will be the address of the next node. For now, the address here is 0, because it's a single element linked list. Let's say this is a linked list of size 5, with numbers 0, 1, 2, 3, 4, the same length as our array, but with a linked list. This is what it could look like in memory. And if we look closely at each node, you'll notice that they contain a value and also an address, which leads to the next node. And that is how they're linked together. We usually call this a node pointer because it's an address pointing to another node. All right, so far we talked about what a byte is and how we access it. We also learned how to calculate the number of addresses of a 1 megabyte memory, and also looked at different ways of memory allocation in arrays and linked lists. All right, so now you have a high-level view of how your programs interact with memory. You're now ready to tackle other data structures. All right, I'll see you in the next one.
Okay, let me set the timer for this one. Actually, I shouldn't close out. Given the head of a linked list, remove the env. Did I do this already? Or maybe I did it another time. What? I don't remember doing this, but apparently I did. Erase. Given the head of a linked list, remove the env node from the end of the list and return its head. Oh, I think I remember this now. Yeah, I probably did yesterday. Alright, I remember seeing this problem, but I don't remember solving it. Given the head of a linked list, remove the env node from the end of the list and return its head. Oh yeah, now I remember. I think I did. I was doing this on stream, I think. The first problem I did with linked lists. So I need to create a dummy that has the okay, let me think. Yeah. Yeah, so the tricky thing about this is that it has to be from the end of the list. Yeah, so what I could do is the same logic as before. Oh, actually, I can't. I was gonna say that I can move one node faster than the other and by n amount, but I can't. Because it has to be multiple of n. So what can I do here? I remember the first thing I thought about when I did this problem was getting the length of the list and then subtracting n and removing that way by skipping. So I guess I can do that. And that's probably not the approach that I ended up doing, because I remember somebody helped me or I watched a video or something like that. But the approach that I thought about was looping through the first one, getting the count, and then subtracting n and creating another loop and make the condition. I want to see if I can remember the other one though. So the tricky thing is, how can I desynchronize them by n amount instead of just by 2? I guess I can make another variable that is equal to n amount. Yeah, that's probably the best way. But I know that this wasn't the solution, or at least this wasn't the solution that I did there. Then I ended up doing. Maybe it should be end equals sad and x. So I think this should work. So I'm advancing, I'm creating a different node that is a different list that is ahead of the first one by n amount. And then I'm doing the same trick from before to find the middle. I'm advancing each one by one. And then because n is more advanced by n amount, when it reaches n, it's gonna run this condition, which is gonna make the next skip the current one. But maybe this is gonna break when I reach. So I also need to make add on next here. Yeah, so I can make this outside. And then I should return dm, .next maybe, or just dm. Yeah, that's the other thing. So maybe I should put. So why doesn't C work? Or maybe it should be a dummy here instead of the DM. It still doesn't work. Probably not gonna work also, but Where does it point to this one? Oh, it should be head on next. Yeah. Oh, it has to be head on next, and here head on next. Probably. Oh yeah, it's because I'm also looping more because I'm going to the end. So this is gonna end first and it's gonna keep counting. That's the issue. I don't know how to get out of this. Maybe if I do a while end, but then I miss the last part of the thing. I guess I can just make another. Yeah, but then how do I catch the beginning? That's the problem. Maybe I could just... So if I was gonna do a straight copy, let me see if I'm thinking correctly. I'll just do head on next. And then let me print VM. Oh yeah, it's because I'm not increasing the head. Oh, it has to be dummy dot next equals. What was I doing that before? Yeah, I was. It also doesn't work. I thought I only had to create a temporary variable when I wanted to reverse the list, but maybe it's needed here as well. I don't see why it would be though. Because it has to be ahead on next year. That's the problem, I think. Yeah, I have no idea. I don't know why is this so difficult for me to understand. It's so confusing. I thought I had got it, or that I understood how it works on the previous one, but apparently I'm still missing something. I don't get why I can't make the next one equal to head on next. It doesn't make any sense to me. I guess I am getting all the values. The issue is that I don't want to copy, I want to recreate. That's the difference. Because if I do it like this, I'm just rewriting the thing each time. Actually, copy will just make it equal to the head, actually. What am I thinking about? And the issue is that I don't want to copy, I want to reconstruct. That's the problem. It's not the same thing. I think that the reason why this is so confusing is because on arrays it's sequentially, but this is more like a tree structure, or yeah, something like that. Because it's not like you're going sequentially, you're just going inside of each level. So you can't really modify the first level. You have to unpack from the last one. Or each level we want to modify is gonna change the reference. That's the issue. So when I'm doing this here, what is going on with this one? That's the mistake probably. I have to make it equal to... I have to do the same thing that I was doing there, I think. So maybe let me change the names. I'm gonna make this equal to end. Let me see if this works. Oh, it has to be end.next here. It has to be equal to head, I think. And I also need to modify the head then. Head.next. Maybe that was the issue, actually. Yeah, so now it's decreasing. No, so I think is probably the way to solve this, but I'm doing something wrong here, obviously. But you create a different node and you advance that node. You shrink the first linked list on this node using the n variable, and then you create the loop on the main one. And when you reach the end of the first node that you created, is the point where you make the node on the other list, you skip one on the other list. I think that's how you solve it.
Hey everyone, welcome back, and let's write some more LeetCode today. Today let's solve remove nth node from the end of a list. So we're given a linked list, and all we need to do is remove the nth node from the end of the list and then return the new list. So that's pretty straightforward, right? So in this case, we got 5 nodes. We just want to remove the n equals 2, so meaning the second node from the end of the list, right? So this is the first from the end of the list, this is the second. So we remove this, and then we return this list, which now has 4 elements remaining. So what's the easiest way to solve this? Well, they say from the end of the list. That's inconvenient. If it was from the beginning of the list, it'd be super straightforward, right? N equals 2, remove this node. How can we make that even easier? I mean, what if these pointers were reversed? Can't we just reverse this linked list, start from here, and then remove the second node, and then we're done? That's definitely a possible solution, but it requires reversing the linked list, which we don't actually have to do. And I'm going to show you the easier way to do it. So let's say n equals 2 again. So we want to remove this node. So how can we identify that this is the second node from the end of the list? Like a lot of linked list questions, we can use 2 pointers, but how are we going to make use of our 2 pointers? So what if I had 2 pointers, right? A left pointer and a right pointer. The left pointer is at the beginning of the list, and the right pointer is shifted by n equals 2. So our right pointer is going to be shifted 1, and then it's going to be shifted again, and our right pointer is going to be over here. So now we're just going to keep shifting our pointers until this right pointer is at the end of the list, and watch what happens when we do that. So we're just going to be shifting each pointer by 1. And this is going to make sure that the space between these pointers is exactly equal to n, which is 2, right? So now we're going to shift by 1 again, making sure that the gap between them is still 2. Now we're going to shift 1 last time because right is almost at the end. So now our right pointer is at null, right? It's at the end of the list. It can't go any farther. And our left pointer is exactly at the node that we want to delete. And the reason is because, remember, the offset between these two is n, making sure that we have the node we want to delete. Now, there's only one problem. We have access to the node that we want to delete, but we want to delete it. How do we delete it? The only thing we have to do is take this pointer, cross it out, and then reassign it over here, right? Once we've done that, we've gotten rid of this node. So the problem is we're at this node when really we want to be at this node if we want to delete this node. And this can actually be solved by another pretty common technique, the dummy node, right? So we're going to actually have another node that we insert at the beginning of this list that we don't really use. And the main thing that's going to happen is instead of our left pointer being initialized here, we're actually going to initialize it at the dummy node. So left is really going to be initialized here, and our right pointer, though, is still going to be initialized over here. So in reality, when our right pointer reaches the end of the list, we will have a left pointer at 3, and then we can update its pointer, removing this node that we want to remove. And to return the new linked list, all we have to do is take our dummy pointer and say return dummy.next, which is going to be this node.
And since this is a two-pointer technique, the time complexity is going to be big O of n. So just like in the drawing, the first thing we really want to do is create a dummy node. We don't really care what the value of this node is, but I'll just say 0. But we want to make sure that the next pointer of this node is set to the head of the list because we're inserting it at the beginning. Next, we can initialize our left pointer to dummy, and we want our right pointer to be head plus 2, right? Or head plus n, whatever n happens to be. So we need a loop to do that, right? We can't just do that with a calculation. So we can initially say right is equal to head, and while n is greater than 0 and right is not null, we want to keep shifting right. So shift right by 1 and decrement n by 1. Because once n equals 0, that means we've shifted by the amount that we wanted to shift by. And the last thing we want to do is keep shifting both of our pointers now. Now we're shifting left and right, and we're going to keep going until right reaches the end of the list. So we can shift our left pointer, and we can shift our right pointer. Now last but not
Yeah, so it's pretty much the thing that I was talking about. But he made with while loops instead. And he made this equals to left. And it doesn't really matter. And then right equals to head. Let me see what the difference in the for loop here. And then it's right on next. Yeah, so this part I think is correct. No.
least, we actually want
Wow, right.
to delete the node. And remember, all we need to do to delete is update the left node's next pointer, and it's going to basically be shifted by 1. So left.next is going to equal left.next.next. So for example, if my
Oh, I guess I understand now. You don't need to keep going until the end because the end of the last one. Because if you change the node that you stopped at, it's gonna change all the other ones. I didn't think about that. Yeah. Then you make left. Dot next, or maybe just left. And then you return that left probably, or DM.
left node was at, my left pointer was at this node, its next pointer is at 2, but I want to set its next pointer to 2's next pointer. So basically what I'm doing is this. And we know that dummy.next is at the head of our list, which is what we want to return. We want to return the updated list. So we can just return dummy.next. We don't want to include our dummy node in the output. We never wanted to add a node to the list. We just wanted to remove a node. So our solution works beautifully. We could have just reversed the list, but we definitely did not need to do that. I hope this was helpful. Don't forget to like and subscribe. It supports the channel a lot, and I'll hopefully see you pretty soon.
And here should probably be 1. Next. And it's probably incorrect because it's giving me none object. Yeah. Here I'm just copying the thing. That's why it's different.
Return dummy.next. We don't want to include our dummy node in the output.
Yeah. Because if it reaches the end of the list first, this is gonna stop, but the for loop is not. And it's still wrong here. So what else? I don't see what I'm doing differently than... Oh, right. Not left. So maybe the mistake was here, not there. But I think this way is probably better because if n... Yeah, but they probably can't pass an n that is bigger than the list. So maybe it doesn't make any difference. Oh, yeah, but in case they do, this one's probably better. Because this one's gonna stop the loop and it's just gonna make the same copy. Yeah, but then it's gonna fail here anyway, so not sure. What the hell? Oh, it's because this is from the head. Yeah. Because if you just make a new empty one, then it doesn't have the next attribute. Finally. But I'm gonna erase this stuff for next time that I try to do this. I think I understand the logic. The logic is not that difficult. The biggest problem is the linked list is really confusing to me. Hopefully after a bunch of times trying to solve these problems, I'm gonna get it at some point. At least that's what I'm hoping for. So I'll do this two once and then I'll take a break. Given the head of a linked list, determine if the linked list has a cycle in it. There's a cycle in a linked list. I think this is an easy one. So the first thing is probably return false. Then while head a equals sad.next, sad.next.next, head equals head.next. If heads.next. Or maybe I should put so pretty much make them both off sync, and if there's a cycle they're gonna repeat. At least I assume that's how you solve it. Continuous following the next pointer internally. Pause is used to denote the index of the node that tail's next pointer is connected to. Probably I'm doing something wrong here. So what the fuck is wrong with this? Shouldn't it break the for loop at the end? Oh, if there's a cycle, it's not gonna break, so that's probably the condition here. Oh, that should be 8 on the next. I need to create trellis, I think. Maybe that's the problem. This looks like it's wrong again. Oh, because yeah, but if it doesn't point to null, then it should break here. Maybe it's because I'm not creating the other variables. Maybe a hacky way to do it is put this on a try set block. But obviously, even if it works, it's not the correct way. Yes, it doesn't work. Accept exception. Yeah, so I guess they don't let you do it. Or I'm writing this wrong, maybe. or put in true x. Okay, now it's correct. So it doesn't return. Yeah, doesn't work. Even if it did, it's obviously not the what they want. So what the hell is going on here? And if I remove this? Oh, I'm not increasing them. That's the problem. Oh, maybe not, actually. Because what matters is the head. And maybe I don't need... Yeah, I don't need 2 pointers as well. Just need one. And if I do like this... And maybe they're not gonna be equal because I'm modifying each time. If I'm moving one by 2 and the other one by 1, shouldn't they meet at some point? Or maybe I do need another one to copy. To copy the head. Because otherwise I... Yeah, but I'm not sure if it would have any difference. The issue is that I can print as well, so... Because it keeps throwing me this error here. Yeah, I have no other idea on how I should do this. I'm not sure what's not correct. Because it makes sense to me. It's probably again something with linked lists that I don't understand. Because the logic seems to be easy. If you move one faster than the other, eventually they should catch up, and then you have a cycle. And if not, then you should reach null, because it's gonna be the final point. It doesn't make any sense for me. I think what's probably happening is that head is not gonna be the same. But it should be. Let me see. Just print. Yeah. Because the thing is, I can't see the structure there. Yeah, I think I'm gonna look at the solution. I have no idea how to do this. Even though I have 9 minutes left. It just doesn't make any sense to me. I'm probably missing something really simple. And it's really hard for me to understand linked list for some reason. It's annoying the fuck out of me. Because even if if there is a cycle, the node that was supposed to be the last one, but is pointing to the beginning one. At some point in my mind, they should meet, because they're moving at a different frequencies. So even if they are different initially, at some point, they should reach the same node. And because I can print there, I can't find any insight. What if I do wow stop? Yep. Obviously this wasn't or maybe it doesn't matter actually. Yeah, it doesn't matter because either way is either gonna reach the end or they're gonna be equal, and then it's gonna be a cycle. And they give you a hint here as well. Or the tail connects to the first node. Maybe I have to put stop.next here. Maybe that's the issue. This is probably the issue. Because I'm always rewriting the same node. Or maybe I'm misunderstanding the way that it's gonna work once it reaches the end, because of the structure of the objects connected together. Yeah, sorry, it's not gonna work. What else can I try here? Let's see if I remember how to reverse it. Hey, Thanos. I think... I don't remember if it was dummy or priv. Or I think I'm confusing the two problems. Yeah, it was priv and then currents. Unknown hats, while currents. Next equals current on next. And current on next equals path equals currents. And currents equals next. So that's how we reverse it. So maybe I can use that to find if there's a cycle. And this is gonna change the current one. But the issue is that I'm pointing the previous to none. So what's gonna happen if there is a cycle? It's gonna be next, then current dot next equals previous, previous equals current. And it's gonna keep going forever. The only other thing I can think about is doing the dot next stuff. Of moving in different frequencies. I think I'll just look at the solution. I don't know how to solve this.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve linked list cycle. I know that we solved a problem that's pretty much a harder version of this exact problem, but in this explanation, I'm going to explain why the tortoise and hare algorithm on a linked list cycle, why exactly it works, and why exactly we know for sure that it's a linear.
Can you help me out? Do you know? I'm having trouble here, especially if linked lists is. I don't know what it is, but it doesn't make any sense to me. The way that it works, it's very confusing to me. I guess it's the structure of the thing where one thing is linked to the other ones, to other objects. I've seen the algorithm while watching a meme video. Yeah. But did you understand it? I'm gonna talk about what I was trying to do, and you can see if you understand why it's wrong. Maybe you understand it. Yeah, but then if you yeah, sure, send me the video, but it's better if you can try to explain to me why the way that I'm thinking is incorrect. If you know as well, because at least so far it's very confusing, and I think maybe other people find it confusing as well, but what I was thinking about is making a variable, and then I increase this variable 2 times, and then I increase the head 1 time. And then I see if the variable that I have is equal to the head, and if it is, I have a cycle. So pretty much because one is moving twice and one is moving one time, if there is a cycle, eventually the one that is moving faster is gonna catch up to the one that is moving slower. But for some reason this doesn't work here. So I suspect that the reason why is because of this inequality here, but I don't understand why. Yeah, really? So that's how we're supposed to do it. I think I remember seeing something like that before. I didn't know, I suspect that probably there was an algorithm, but I didn't know the name. And I remember watching a video or something about that a long time ago that mentioned this, and I think it was on the back of my head, especially doing the other ones, the other challenges. It seems like this should be the approach, but it doesn't work. I don't understand why. I'm probably doing something wrong here. It's just really annoying, this linked list. Hopefully at some point it's gonna click. So this is JavaScript, right? So you're looping until n and n dot next. If e equals e dot next equals n dot next dot next. Different than 0 is true, different than 1. Is the tortoise and variable short. I use JavaScript because it's really flexible. Yeah. I think I don't understand this part here. I think the difference between your thing and mine is that you're making this equality here, and I'm making between e and n. Let me copy this and see if I can replicate the same thing, but on the way that I'm doing there. So I think it would be the same thing that you're doing here, but like this instead. But I just don't, no, maybe not, because you're assigning the value. Yeah. I might have messed that up because it wasn't a recent solution I made. I generally solve at nights, so it might be a mistake. Oh, also that maybe video talking about tortoise and her is here.
Doing this in linear time and constant space.
Oh, I really like this guy. His channel is great. His latest videos are
Doing this
really
in linear time
well
and
made as well.
constant space.
I was just watching his other channel where he's explaining some stuff.
Requires Floyd's tortoise and hare, a simple cycle detection algorithm where one pointer traverses twice as fast as another, and once they meet, you can trace back to the point where the cycle began. In our case, The values of the array is like a pointer, pointing to indices of the array, which is like nodes in our case. Because each number is from 1 to n, then each value will have to point to a valid index, and since there's a duplicate number, there will...
But I think it's just a different way in syntax. Maybe not. I just don't understand well. Because in my mind, you're making the assignment here, and I'm making here. So the only difference is that you're writing everything in one line. But maybe not. The only thing, maybe if I do 3, but I don't think you can do this in Python. I don't remember really well. And maybe if I remove this, but I think I tried this before as well. And should wait a little bit. Yeah, sure. That would be great. My concern is that I watched the solution from the previous 2 problems and I did them a bunch of times, but it seems like I'm still missing something fundamental that I can't really understand about linked lists. I don't know why. It's so confusing to me. And it's really annoying.
will be a cycle. Find that cycle, and you will have your answer. What are you waiting for? Code it yourself. Senior engineers don't code anymore. Also, my doctor said not to, because of my carpal tunnel.
Oh, so this is the Python solution.
That works. Senpai, why are you so smart?
Because I'm a gangster.
That works.
But this is for lists, not linked lists.
That works. Senpai,
Yeah, man.
why are you so smart?
Because I'm a gangster.
I think I'm gonna watch
Linear
the
time
solution from
algorithm,
the
because I
guy.
think most people just kind of glance over why exactly this is true. So I'm going to go over that today. And you can see that this linked list problem is
And if I couldn't solve all of this, I'm definitely not gonna be able. But I'm still gonna try to solve this hard one, because why not? Or probably the one. Yeah, I don't know how hard. Dynamic programming is also really hard from what I've seen. To suspect the ones that I'm gonna have the most difficulty in is gonna be linked lists and dynamic programming probably. Yeah, but the rest doesn't look easy as well. I think arrays and hashing is probably the easiest out of, and 2 pointers as well, out of all the other ones. Maybe stack and binary search relatively easier as well.
another problem from the blind 75 list, a list of 75 problems we've been working through and tracking on the spreadsheet. The link to the spreadsheet will be in the description if you want to take a look. We are not quite done with this sheet yet, even though we have done pretty much most of the difficult, medium, and hard problems on this list. So basically, we're given the head of a linked list, and we just want to determine if there exists a cycle in this linked list or not.
Okay, so first we check if there's a head or not. And thanks for the follow. It's probably you, Thanos. That I should initialize outside. I tried putting a break statement, but then it just gave me a message, but it didn't do anything. And thanks for the follow, someone else that I can't read, but yeah, thanks. And you don't modify. But the thing is, yeah, you could be right, but the thing is that at least the way that I was thinking is if there is a cycle, it's going to return true here. And I tried to put break statements here, but it doesn't work as well. It just shows me a message. There's probably something else. I think the problem is... Oh, now it shows false. I was doing here, so maybe that's why. Problem is probably that I have to... And that's weird. So it's probably the way that I was doing... Yeah, because I was creating a different node, maybe that's it. But obviously this isn't correct anyway, because it returns false. Or it just runs forever. And here you're initializing both of them outside. It's as though equals head duck next. Yeah. Well, is low different than fast? If not fast, you should take a look at binary search. It is a platform. Like, oh yeah, I've heard about it. It's, I think I have it open here in the other browser. But I'm gonna leave the binary search problems for later, because I'm still very beginner, very noob. I suck at this, obviously, because binary search, but you can solve problems co-op, and the problems there are much clearer. My head is so bad, you know. Take a look at binary search. I'm doing this list here from this guy that has this awesome channel I really liked. And I really like this site here that he did. Makes things much easier. So there's true lists, blind 75. Then some people yesterday told me to follow this blind 75 list because it's better. I was doing this 150. And my idea is to finish this list, then do the list again. And the more times I do the list, I'm gonna start training Vim key bindings as well. So the next iterations, when it becomes easier for me to solve these problems, I'm gonna train to use the Vim bindings while I solve the problems as well. So I can learn two things at the same time. And then once I'm good at this list, I'm gonna move on to the 150 list. And then maybe after I do this enough until I can solve it very easily, then I move on to binary search or maybe other problems in LeetCode, hard problems. What is the dark? Someone else told me dark reader, this extension here, allows you to make sites dark. Probably use dark reader. It handles the dark theme much better. Yeah, that's the one that I'm using. But I changed this thing here to Monokai, the theme of the ID. Vim so chat, but I broke Vim on my system and can't use some plugins unless I use Linux. So I moved from Vim to VSS. And what about Emacs? Can you use Emacs? I'm thinking about training Vim because it seems like all the best people or the people that have been programming for a long time use either Vim or Emacs, and probably makes you a lot more efficient. And since I'm gonna have to learn it anyway, it's probably better to just learn it, just get over the initial resistance. Because in the beginning, it's probably gonna be extremely annoying to figure all this stuff out again. About how to set up the environment and all the key bindings and stuff like that. New Vim, what's the difference? I'm thinking about later on moving to Emacs as well, once I'm comfortable with Vim. Because it seems like Emacs is a better version or with more things than Vim, but I'm not sure. But obviously it's gonna take me a very long time to do all of that. And it's probably gonna be very painful. Hopefully, eventually I will learn. Fork of Vim, but better code base and up-to-date. Oh, okay. I'll keep that in mind. But the issue is are the key bindings the same? Because I think here there's only standard Vim and Emacs. I thought this was a good idea because then I can do two things at once. I can train the problems and at the same time learn the key bindings. Seems like a good strategy. First off, to use key bindings is much worse. Improvise your key bindings as you move forward. You need to delete fat lines and delete things between double quotes. So use key bindings for them. But it's doing the same task over and over. That's why I bind. Yeah, the issue is you don't know what you don't know, right? I guess I agree with your strategy. I think it's good. But I just don't know. Yeah, the best practices. I think the way that I'm thinking about it is I'm gonna keep a spreadsheet or something like that with the common bindings first, and then I'm gonna get used to using them as I solve LeetCode problems. Once I'm comfortable with solving the problems, because it adds an additional challenge to it. And then once I'm used to the general stuff, then once I go back to doing projects, I'm gonna move to Vim, and then once I move to Vim, then I can do that. Where whenever I need something or I feel like I'm doing something too much, I can see if there's a binding for that. But I can't really, because it's hard to start from zero, right? I don't really know anything, so. Transparent table, input of Vim key binding cheat sheet under the table, under your hand. Yeah, exactly. And then I keep looking at it and trying to incorporate at least the basic stuff in the beginning. Did you feel a huge difference when you're moving from one to the other? You guys are not there. And so I'm just gonna try to understand the solution here. New Vim had much more extensibility, so I spent 90% of my time configuring Vim. 5% of the time coding, and 5% of the time thinking about what I'm going to code. Yeah. The beginning is probably really annoying. And that's the stuff that's putting me away from learning for some time now. But I'm gonna get over that. So here is the same idea that you're using. But you're returning true as default. So initialize one in front of the other. And then you move twice. That's another difference, I think. So maybe if I do next here. And then the condition is also different. I spent around like 1 week to fine tune my VS Code, but I spent 3 days. Oh, really? Because look at the condition. Was low, different and fast. Yeah. But I also think it's the if statements there. So you're doing this. Or because you're creating 2 different variables. And I'm modifying the initial one. But that shouldn't matter because you're also modifying. Just load the next. And let me see if this way. I would think that VS Code takes a lot less than NeoVim to set it up. I remember having some issues with doing things, but maybe you have extra additional features as well. So I wonder if that other condition is necessary. I probably asked because you need to return false as well. And it's still... It annoys me that I don't understand how it works. Fast. Yeah, there we go. The main difference is the equality operator here. Yeah, that's the difference between the way that you are doing and I did it. Because you're checking to see if they reach a null. Yeah, because at some point they're gonna be the same. If there is a no, they're gonna both be no. So they're gonna break the while loop. That's the difference. And the way that I did it, I'm checking to see if they're both equal, but I'm changing them each time. So that's the key thing that I have to understand, is the difference between each node specifically, because each node has a connection with all the other nodes. So you can't make one equal to the other. But I don't understand why. Yeah, it's still a little bit confusing to me. And the rest is the same, obviously. Ah. So this doesn't pass. Oh, because I didn't put the condition there in the top. Keep doing the... Yeah, there we go. Yeah, so let me look at the solution from this guy.
And basically the definition of a cycle is if at some point, you get to a node and you keep following the pointers along that node, eventually you'll get back to the same node. And if we get back to the same node, we'll be able to do it again and again and again, basically an infinite loop. So we return true if there's a cycle, we return false if there's no cycle. Now the first idea you might have is just start at the beginning, keep going to the end, keep going, and eventually let's say that this -4 actually pointed to null. In that case, we know, okay, we got to the end of a linked list, right? So in that case, we return false, no cycle. And that's always going to be the case. So if there's no cycle, it's really easy to detect that there's no cycle because eventually we reach null. But if we don't reach null, right, we go along this node and we get back to the same node we already visited, but for some reason we can't detect that. So then we go to the next node, and keep doing that. And from our perspective, we're just going to say, okay, it's just a really long linked list. Eventually we're going to get to null, right? But that's not going to be the case. If there's a cycle, we never get to null. We'll never break out of this loop. So we really have to determine a way to detect that we're visiting the same node twice. So how can we determine if we're visiting the same node twice? Well, we start at the beginning like usual, and we maintain a hash map or a hash set in this case, where basically we take every single node and we take the node itself and add it to the hash set after we have visited this node. We don't add the value because I think in this problem there could be duplicates, right? Like the same value could show up multiple times in multiple nodes. So we don't want to detect a loop that way, but we'll take the node itself and then add it to the hash set. And I think you can do that in most languages. You definitely can in Python because the node itself is just an object and you usually can hash an object. And so in that case, we're going to take this, visit it,
Thanks for the follow.
take this, visit it, take this, visit it, and then eventually we'll get back to a node. If we notice that a node has already been visited and now we're visiting it twice, that obviously means that there must be a cycle, right? We can't visit the same node twice. So that means there's a cycle. We detect that, and then we can return true, a cycle exists. Now, in this case, we're only having to visit each node about once, so the time complexity is going to be big O of n. The memory complexity is also going to be big O of n, because every node potentially is going to be stored in the hash set. But there's actually a way that we can do this without using a hash set. We can do this in O of 1 memory, and that's the slightly complicated algorithm. I'm going to show you that algorithm, and I'm going to show you exactly why it works. So the idea is simple. We're going to start at the beginning of the linked list, but we're going to have two pointers this time. We're going to have a slow pointer S, and we're going to have a fast pointer F. And you may have seen this algorithm before. It's a pretty simple algorithm once you know it, but I'm going to again show you why exactly it works. So the slow pointer each time is just going to be shifted by 1. The fast pointer is going to be shifted by 2, so it's going to be here. And so originally they do start at the same position, but we're going to look at every position after we've shifted it. And so what's either going to happen, obviously the fast pointer is faster than the slow pointer. So if there is the end of a linked list, right? Like for example, this points at null, the fast pointer is of course going to reach the end of the linked list first. So if we do that, then we can return false, no cycle exists in the linked list. But if there is a cycle, do you see that this fast pointer and this slow pointer are going to meet again? They're going to meet at the exact same position. And if they meet at the exact same position, that must mean that a cycle exists. So I'm just going to run the simulation, and then I'm going to show you why it's always going to be the case that these two are going to meet if they ever reach a cycle. So we just take one more step with S, right? We're only shifting it by 1. F.
I guess linked lists are very similar to graphs, probably, which is not really exciting because I suck at linked lists, but if you think about it, a graph is just a collection of double linked lists. Or is one big double linked list? Probably. So it's probably the same type of logic that goes into both. I would assume. Or maybe not. But if it is, then yeah, it's probably gonna take me a long time in the graph section as well to solve the problems.
Is going to be shifted by 2. So first we're going to go to 4, and then we're going to follow the link and reach back to this position, right? The 2 position. So clearly F made a loop. F has gone through the cycle. And so far we've shifted each of the pointers twice. And so we're going to do one last shift. S is going to reach the 4. And our F from over here is going to be shifted twice again, and it's going to reach the 4 as well. So at this point, we're going to see, yes, the slow pointer and the fast pointer have met each other. How could it be possible that they met each other if the fast pointer was going twice as fast? Because they were in a cycle, and eventually the fast pointer, no matter where they start, slow is here, fast is here, eventually the fast pointer is going to catch up to the slow pointer. Let me show you why that's always going to be the case and why it's going to happen in linear time. So let's say this is our cycle, and I'm not drawing it as a linked list. It's some kind of circle, right? And it's a cycle. And let's say we're moving clockwise in this cycle. First thing to notice is, do you know that every gap, so let's say, the distance between slow and fast, that's going to be some integer value, right? It's not going to be a decimal, it's going to be an integer value. And this portion is also going to be an integer value because the entire length of the cycle is going to be an integer value because, linked list lengths are integer values, right? This is an integer 1, this is an integer 2, also 1, so the entire list is length 2, right? So we're dealing with integers here, not decimals. So we're looking at the case where the slow and fast pointer are at different positions, because obviously if they were already at the same position, we're inside the cycle, they're at the same position, then of course we know we're going to return true. But it could be possible that they're at different positions. Any arbitrary position is what I'm choosing here. And we know that the slow pointer on one iteration is going to make one jump, right? The distance it's going to move is 1. We know that the fast pointer is going to move a distance of 2, right? So clearly, in our simulation, eventually the fast pointer is going to reach and surpass the slow pointer. But why is it true that they are going to meet each other at the exact same spot? Well, let's just give this distance an arbitrary value. We know that the fast pointer will catch up to the slow pointer, and this is the distance that it's going to have to travel in order to do so. This is our gap that we have to close. So let's say the length of this gap is 10. If we move the slow pointer by 1, we're taking the gap and increasing it by 1, right? If the slow pointer gets shifted by 1, we increased the gap. But then the fast pointer is not going to quit. It's going to move by 2 as well. So when we move the fast pointer, we're taking the gap and closing it by 2. So we're saying plus 1 minus 2, right? Do you see how this distance is linked list, right? So that's why. So like I said, we're going to start our slow and fast pointer at the same position. The slow pointer, the gap, but then the fast pointer.
The time complexity.
Could this gap possibly be? It could only be the entire length of the list. So, let's say the fast pointer is over here where this distance is 1. So then the remaining distance is going to be the entire length of the list. Let's call that
Makes
n.
sense.
To that now. So like I said, we're going to start our slow and fast pointer at the same position, and the next time that they meet each other is how we know we've detected a loop. So obviously they're at the same position now, so we don't want to say that there already exists a loop because we don't know that for sure. And we're going to be shifting our fast and slow pointers while fast and fast.next is not null, because we need to make sure that fast.next is not null, because remember we're shifting fast by 2 on each iteration. And of course fast is going to reach the end of the linked list before slow does. So if it does that, then outside of the loop we can return false, meaning that there does not exist a cycle. But on the inside, we're going to check if there is a cycle. So we're going to take our slow pointer, shift it by 1, slow.next, take our fast pointer, shift it by 2, fast.next again. And now if they meet each other, we can say if slow ever reaches fast, then we can return true, there does exist a cycle. And you could pretty much write this loop.
So I guess the only difference between the way that he does it and that I was doing is that I was initializing the other node as an empty node and not head. That's why. So they become fundamentally different, because even though I'm making one of the nodes equal to the head, not next. Yeah, because I'm jumping one. That's the thing. So the one that I initialize should be the slow one always, and the fast one should be the head. That was the mistake I think I was making. Yeah, because if fast is no, if the list is not a cycle, either one of them is going to be no. And I think you have to make both the conditions, because you're testing based on the gap. So you have to check for both fast and both fast on next, because they're going to be out of sync. So the difference between this and the way that I was doing is that I was initializing a node to an empty one, I think. That was the mistake I was making. And then this makes the two linked lists fundamentally different. But maybe if I make the one that I initialize as the head first, it works. I'm not really sure. So let me test. So while add and add on next. And he also didn't make it like this. He created a different variable, so that might be another thing. Let's. Or actually, it's low. And then head equals next, dot next. So maybe now it works. Not sure about it. If it doesn't work, the next thing I'm gonna try is initialize another variable here. And make it equal to next to head. And so it doesn't work. Also makes fast on next. So maybe if I do slow down next. If that doesn't work, then it means that you have to initialize as head, so you can compare both of them. Also false. Yeah. Now let's see if I make this equals to head instead. Maybe it's not gonna work as well because I have to make 2 copies then. Because when I do this, I'm changing the initial one, which is gonna change this one. Because this becomes something different each time. That's the problem. So by the time slow gets there, it's already different. So you need to make 2 copies of the initial one. That's the issue. But I'm not sure if I get it now or if I still. And maybe I should do fast here as well because fast is gonna go faster, obviously. I think. And so he makes fast. And this should pass. Oh, and it also is equal faster. Slow equals this node will work because it's empty. But in which case, I'm not sure if it works, or maybe I'm doing something else wrong. Oh, here, son. So what else am I doing wrong here? So fast. Oh, it's low. Yeah, slow dot next. Fast on next. Yeah, I think the biggest issue between the way that I was thinking before and this way is that I was modifying each list differently and then I was comparing them. And that's why you probably need to separate. But you're talking about I don't think it's possible to do like this also. Unless, but maybe if we make head equals head on next, maybe it works. Oh, it works. Okay. So the only issue is I was modifying them differently and it wasn't working because of that. And now I should probably check as well to see if they exist or not. there's